Very good morning. Now let's settle down. We'll start the inaugural session. This is 10 o'clock, 10th of October, 10/10/25. Very good morning to you all, ladies, gentlemen, dignitaries. And it's a pleasure to welcome you all in the City of Joy once again in the 20th seminar in series of Steel Tech. And we are so overwhelmed with your response in all the seminars and these seminars as well. And it's a festive season. I know many people have some, festivity. In spite of that, you have come in a big number like before, and I want to congratulate you, and we are really happy, and big round of applause for all of us. Thank you. You know, our seminars, Steel Tech seminars, are popular because of you, the dignitaries who have come. They are from research institute, service provider, industry leaders, and all these other people who are attending this seminar. And we do always on contemporary topics, and this topic is also very important, as you know, like application of AI and other tools for sustainable, cost-effective steel making. And as you know, the industry cannot do without becoming sustainable. And also, they have to be efficient. And in that way, even there are forums which are setting the world world will stay, but human being cannot exist if you are not sustainable. So therefore, all over the world, this type of seminars, deliberations are taking place. As you all know about the SDGs, and there are many things. And I'll be very brief. I promise that I'll be very brief in my speech, because if you have seen the program, there are so many dignitaries, so many experts, and we want to learn them, we want to listen to them and learn whatever we could guess it, and I'm sure we all will enriched with their deliberations. As you know, the India is growing, so also Indian steel industry. India from 10th largest, about a decade back, we have already become 4th largest, and we are going to be 3rd largest in a year or two. So therefore, good going with our lot of efforts, enthusiasm, and positive vibes. And so also the industry, steel industry, we are now from there, as per the plan, we are going to achieve 300 million ton by FY31, then again by 47, maybe 500 million ton. That is Bikasit Bharat, Bikasit India, and we are all part of it. And also sustainability, as I was mentioning, that India also, they are committed to become sustainable by 2070. So also the industries they have mentioned, they have become carbon zero by 2045 or 2050. So therefore, this seminar is very important, and the deliberation will be very, very, intense. I'm sure we will be enriched by that. And I may request that every one of you to be effective and be careful and listen. And before I conclude, I'd like to request Safety Officer Debashish of Taj Bengal to give brief on safety. Thereafter, we'll start the proceedings. Debashish.
Thank you, sir. Good morning to all of you. Welcome to Taj Bengal Hotel. I am Debashish Shah, Safety and Security Executive of this hotel. I will brief you on the safety and evacuation routes in this particular venue, Crystal Hall. There are 4 emergency exits in this hall, 2 on my left and 2 on the right side. All emergency exits are safety evacuation routes, which leads you to the safe area at the banquet porch. At the banquet porch, we have a demarcated assembly point for all together in case of an evacuation. We have a team of certified first aiders, firefighters, and CMG, that is Crisis Management Group. Kindly carry your valuables while leaving the hall. Please inform our staff in case of any emergency. Thank you and have a nice day.
Thank you, Debashish. We are safe here. There's a lot of arrangements. As I mentioned, I'll be very brief. I'll not go further. So I request you, all the presenters, also to follow the time because there are many speakers, many presenters, many people, dignitaries will address us. And with this, I conclude my first, small address. And now I have a pleasure to call upon the dignitaries one after the other. And it will be my pleasure to request Mr. Jayanta Banerjee, CIO of Tata Steel, to address us. He could not come in physically, could not make it to Kolkata, but he will be online. So before handing over to him, may I very briefly tell about Mr. Jayanta Banerjee. He is the CIO of Tata Steel, and he is a member, senior management team member, a thought leader in digital, spearheading IT, digital, industrial automation, and AI-led digital and Industry 4.0, 5.0 transformation to create business value and being patiently impatient to drive the change. Before joining Tata Steel as a CIO, Jayanta was business leader in TCS, driving the products and platforms business and asset monetization strategy and governance. Jayanta has been the business leader and global head of TCS Energy and Resources business. Jayanta has been with Tata's for 32 years and has led business, strategy, sales, delivery, operation, and IT digital globally. Jayanta has played a key leadership role in industry initiatives specific to manufacturing, life sciences, CPG, energy, and natural resources. He has spearheaded strategic transformation in these verticals. He has been instrumental in nurturing many strategic partnerships for TCS and is now driving a significant business value transformation program at Tata Steel as a CIO, leveraging new age digital, IT, industrial, automation, and AI. He has been an extensive traveler and speaker across the globe and takes a keen interest in groundbreaking initiatives. Jayanti is also on the board of Metal Junction Services Limited, Tata Steel Business Delivery Center Limited, and also works with several industry bodies and forums, including the World Economic Forums, MIT, IFQM, CII, and other industry AI 4.0, 5.0 initiatives. He is an active empaneled member of the World Economic Forum, Advanced Manufacturing Council, IFQM Digital Chapter Chair, and MIT Gen AI Consortium. He is also an alumni of CDEP France, AIMA Berkeley, and Ross School of Business. He is actively into fitness and mentor to the aspiring leaders of the IT industry. I understand he'll be also covering the demystifying AI and industrial AI. Please welcome Mr. Jayanta Banerjee with a big round of applause. And over to Mr. Banerjee, please. Thank you.
Okay. I believe I am audible and visible because I can't see anybody, I can only see the stage. I would request if we can face the camera towards the audience, at least I'll be talking to the audience, if that is possible. So I can only see the back of the audience, not, but that's okay. Am I audible? Can somebody confirm? Okay, I'll go ahead. So I'll talk about AI and
You're loud and clear, Jayanta. You're loud and clear. Yeah.
Thank you very much for confirming. Okay, so I will be talking about AI in the next 15 to 20 minutes max. And I would like to demystify AI first before talking about AI applications within the steel industry or a heavy industry per se. See, AI is not a standalone technology. That's the first demystification I would like to do because there is a common myth and belief that AI, if we apply, it will do wonders. It does not because It needs lot of supporting backbone technology before it can be implemented. Now, today, as you know, there is a euphoria regarding AI that is going on. Everybody talks about AI. AI is everywhere. We have kind of renamed companies saying it is .ai, AI enablement. All of that is happening, and there is a reason for it. I call it ubiquitous AI. It happened to digital. It happens to any technology hype. But this particular technology hype has been a super hype and is going on for long. Now, having said that, as we know that AI needs data to feed upon, and data needs cloud and edge technology to feed up to build itself, right? So there has to be a sequence to do AI. It has to be cloud or edge. It has to be data technology, and then only you can do AI, in generally speaking, in that strict sequence. Having said that, I would like to now talk about the hype a bit. Now, you cannot complain because it is the job of Silicon Valley to export hype in the world, and it is their statement, not mine. And hype has its pros and cons. Any hype or super hype of technology always creates wealth, creates investment, creates business opportunities, creates awareness, which is important. But at the same time, it becomes imperative to be realist, okay, and also stay optimist. But the point is that if we do not understand how AI works at a conceptual level, then we will go down the line, invest in AI, but we will not get the ROI or the return on investment on the investments that we have made in terms of business case and all that. But I will come back to AI. Let me take you back to the last 40, 50 years, what has happened to technology. I think that is very important for us to understand in order to understand AI today. If you look at early 90s, and by the way, while I'm speaking on AI, I have done my thesis, my master's in AI in early 90s, 89, 90. So AI was there even 40 years back, right? At that time, we used to loosely call AI as fuzzy logic, right? Something between 0 and 1. And today, again, you are hearing about quantum computing, which is nothing but infinite possibilities between two deterministic states, that is 0 and 1. I'll not get into quantum mechanics or quantum physics now, but the point is AI has been there for the last 4 to 5 decades, but in a different form and shape. What used to be then called AI is fundamentally mathematics and scientific models, right? First principle models, as we call it. There is a term we use technically to define that as narrow AI. Narrow AI fundamentally solves very specific scientific or business problems. You know the problem very, very clearly, and you use certain theories and theorems and constructs and science and optimization models to solve that problem. It is a point solution, which is absolutely fine. But what happened? How did IT industry get into all of this? Let us take a pause from AI for a bit. We all know about year 2000 and the Y2K problem, right? So it started around 1998. The whole IT industry got prominence because of the Y2K problem. In my view, and I was a part of the journey, but in my view, it was a completely avoidable problem. It was a 2-digit versus a 4-digit issue, easily avoidable, but for whatever it is worth, the IT industry made its prominence riding that Y2K wave, right? And a lot of system changes happened at that time. But soon thereafter, there was another super hype, like the hype of AI that is going on now, that was on ERP, Enterprise Resource Planning Systems, which fundamentally drove standardization. And that is the point I want you to kind of take note of, that this hype lasted, and still it is going on, though it is all commoditized today, for almost 2.5 to 3 decades. And that's a very longish hype in a technology cycle. Typically, a technology hype lasts only 1 year or 2 years max. Now, the whole world then drove standardization, because if you are doing finance and accounting, if you are doing HR, every organization has similar processes. So there is no need to create a new process or design a new process or think about a new process. You can just have a simple standard code, and that is what an ERP does. So that drove standardization across industries, across the globe. Now, after that, what happened? Something Similar euphoria happened in 2006 to 2008. And all of us, possibly in the audience, everybody has gone through that. Our families have gone through that. Our children have gone through that. That is, we exchanged our own personal data in exchange of a smart screen. That's all as a human race we did. All of us carry a smartphone today. And what it did to us is that it changed the way we commute, we collaborate, we communicate. Everything changed thereafter. 2006, 2008, that was the inflection point. We gave up our personal data, and companies like Amazon or Google or Apple, and there are many, who kind of rode that wave because they were infrastructure providers at that point in time, and they used to acquire the data. They used to provide us cloud infrastructure, a third-party data center. All the data got mined into their data centers, and the market capitalization of all the oil and gas companies started receding, and the technology companies gained the prominence in market capitalization across the globe, and all of us have witnessed that. That changed the society. That changed to generations that are coming now as digital native. That was the inflection point then. And that was the bedrock for current generation AI, right? Now, once we have driven the wave of standardization and then driven the wave of data democratization, that is what happened in 2008 and onwards. Our data was no longer our data, it was on the net, and anything that goes on the internet can never be deleted, is permanently somebody else's. And whatever law you try to protect, it never can be protected. Nothing can be deleted in the tech industry. Nothing gets deleted as well. So when it happened, then there was another phenomena that started, and that started with the new generation. That was that I want to claw it back. I want to bring the data back, my personal data back to me. And that, if you might have heard about it, must have heard about it, that something called personalization. So then people say that I want to personalize service, I want personalized effects, and I need the data back. So that drove a completely opposite trend to standardization and data democratization, right? And that is where the new generation AI, what you now see, the euphoria started in inflection point was in 2022. All of us heard about generative AI. It was December of 2022, January of 2023, rather, the first version of ChatGPT was announced and generative AI was launched. And thereafter, in the last 2 years, I have seen there is a sixth generation of AI that has transformed in last 2 years alone. So if you look at the technology trend, ERP from hype to commoditization took around 2 decades, 2.5 decades. In between, after data, cloud happened. Cloud took around 10 years towards commoditization, right? So it is available to everybody. And what did cloud do? Cloud actually, it started its being in around 2015 and lost its hype around 2025, or it's just getting commoditized. What it did to us is that you don't need to go to compute and data. Data comes to you, data stays with you, you carry your data along with yourself, right? So that is what it did to us. But that did change a lot of business model. All of us have seen Amazon, Zomato, Blinkit, whatever we use and leverage, all and Netflix, everything is a business model change driven by cloud, fundamentally. And industries are getting transformed because of cloud, because you have access to, just to give an example, in our company, in steel, in 2018, we had access to 6 terabytes of data on a click of a mouse. We could access 6 terabytes of data. Our steel industry does not generate only 6 terabytes. It generates a lot more data than that. Today, we have access to 11.2 petabytes of data. It's an exponentially higher number in the same company at a mouse click. That is the level what cloud can bring to us. That is the scale that cloud gives to us, right? And that is extremely, extremely leverageable. Now then, what happened? What is generative AI? We need to understand. Generative AI is a technology which is completely different from a narrow AI technology. One is science-based, other one is fundamentally communication-based. How humans think is cognitive-based. It is cognitive thinking. So technically it is connecting nodes, but that is fine. So you have heard about LLMs and SLMs and agentic now. So large language models and small language models, the difference is only in the number of parameters it handles. Very simplistically put, a LLM will handle 1 billion parameters and SLM will handle much smaller. SLM will solve very specific point solutions and LLM can do much larger creative thinking. Now people complain that these models hallucinate. Yes, they're designed to hallucinate. So they are supposed to hallucinate. Now, when you use generative AI in an industrial context, you need deterministic output. You will not get it unless you do a temperature control. There are ways to control the temperature and ask it not to be creative. Now, that way you're not actually leveraging the power of generative AI. Then it is better to do mathematical and physics-based AI, which will give you more deterministic scientific outcomes. Generative AI is designed to think like a human, to be creative, and can generate content. That is how it progresses. Now, today, if you look at, today experts, the scientists and godfathers of AI, whether in MIT or in Silicon Valley, they are saying LLMs are dead. And I agree with them because LLMs have been developed to learn from the internet for whatever source of body of knowledge is out there. It learns very fast, but it memorizes that. It reads that and produces outcome by connecting nodes within that. But that is not what humans do. We learn in a different way. We do memorize and learn. We also have adaptive learning. We learn from the universe, from the life around us, right? That is where the next generation models will develop into. Now, why we are doing all these things in AI? What is it? It is just a transitionary phase. What is the end goal? The end goal is to go to first artificial general intelligence, which is a human intelligence. When AI reaches that stage, it might take 5 years, might take 20 years, I don't know. But whatever be the pace of evolution, it is a part of the human evolution. AI will evolve into something exactly like human thinking. That is AGI. After that, the next phase, as the scientists call it, is ASI, that is artificial supreme intelligence, which will be more intelligent than the humans. And that is where the societal danger is, and that is what scientists are trying to protect. That if AI becomes more powerful than humans, then what will the society be? Now, there is also a stream of thinking which is philosophical, I'll not talk about it, that it's a part of evolution. Humans might, after 509 years, which is very small in terms of evolution, generate into semiconductors as a next species, but that's a different discussion, different day. But whatever it is, the point is it is just a transitionary phase. Now, today, we have moved away from LLM to agentic. And what is the power of agentic AI? It stops hallucination because think of agents as individual human beings. But agents cannot work alone. Agents work together with other agents. So agents are a specific expert on a particular subject. They do a specific job. And another agent can do a specific job. You create a team and agents need a leader, which is called orchestrator. And agents are, that leader then directs the team of agents to do something. Benefit of an agentic architecture is that agents learn from each other, they reinforce each other, and that is why there is a governance, there is a model policing that happens, hallucination is slowed down, and it is extremely, extremely powerful. Today, if you have to apply artificial intelligence, generative AI in your organizations, in the industry, you should start from agentic and not from LLM because it is a very different technology and very different leveler, I would say. Now we have spoken about AI, and after that we can speak about physical AI, autonomous operations, and robotic systems, and all of that. But there is a demystification that I want you to carry with you all is that none of this is possible without the correct data, without the correct context. Generative AI cannot work without the context. AI generally cannot work without data and quality data. So the focus before you invest in AI is to invest in data technology. There are data ontology techniques, data taxonomy, definition of data, and all of that. Otherwise, it will be garbage in, garbage out. It will create exponential problems for any industry. Now, coming to steel, so if you look at the steel value chain, many can argue, and you are all experts sitting in the audience, and I am not a steel expert, but I understand the context. Steel is essentially called a very physical heavy industry, an asset heavy industry. But if you look at steel, it is high temperature, high pressure, high vibration, right? So and have you been able to touch a molten metal? You will not be able to. So essentially you monitor, govern, run the operations remotely. Even if you are 35 feet away, 100 feet away, you are running every operation, most part of the operations remotely. So it lends itself extremely well to digital transformation, AI-based transformation, because it is essentially remote operations. That is where, if you look at, see the transformation that we are driven in Tata Steel, we have moved the physical industry, the mindset and the physical industry operations to more and more of remote operations model controlled. Today, we are running around 625 AI models in the organization at every aspect of the value chain, and 47 billion tokens of generative AI has been consumed in a very orthodox physical industry. It is very much possible. If you look at the value chain, right from raw material procurement, where model decides and gives that intelligence layer to the human operator, where to buy, when to buy, how much to buy, from that spot price prediction to the inbound logistics to when it comes to the furnace, what will be the chemistry that will go into the furnace, which will produce an optimal output, right into the steel making where we are focused on defects and can we identify defects more upstream than identifying the defects on the sheet that has been produced, going to the outbound logistics, supply chain optimization, and then ultimately going to the customer. And if you have seen some of the publications of Tata Steel outside, that how we are trying to deliver steel within days, within 72 hours, and we have made it possible using technology, and which is mostly a combination of both physics-based AI and generative AI, and that's a very high-level summary. I think there's a lot. There is the seminar that you are attending is also about sustainability. So AI modeling actually can optimize your operations to help in emission control, and we have done a lot of it. Your emissions are inevitable, but unless the technology changes to a different steel technology altogether, but in the current methods, you can use modeling to optimize your input conditions, optimize your input metallurgy, optimize the output conditions, and also do emission control in terms of stack emissions and whatever. So there is a lot that can be done. Remote operations itself is towards reducing carbon footprint. But also we need to keep in mind, while you do all this AI modeling, it utilizes a tremendous amount of compute power. So while steel is 8% globally, as I understand, cement might be 15%, but it is projected that AI will contribute to 5.5% of emissions globally. And the time is another year or 2 years. And that is a very dangerous statement. So we cannot be irresponsible in using AI. The point is, if you just do mindless AI, there is a lot of social media kind of TikTok videos that are going around. Everything is using image-based AI and all of that. Does it have a significance? Or is just a game being played? And every image-based AI is using so much of compute in the data center, and which is creating emission. So we need to be mindful, we need to be responsible, and at the same time, AI, if it is in the perpetrator's hand, in the wrong hands, it can create menace, right? And all of us should be aware of it from a cybersecurity perspective, our safety, our family's safety, that AI as a technology is extremely powerful. And if you are using it to clone, for example, you do not know today that whether it is me speaking or my avatar speaking, right? You have to just trust. So that is the level it has gone. So the use cases are numerous. Point is, my only advice, my only suggestion, my request will be that don't start from AI. If you have to do AI, start from cloud, invest in cloud infrastructure, invest in data. This will take a long time, lot of investment. Then AI will automatically happen and the technology will mature over a period of time. With that, I'll stop here, pause my presentation. Thank you so much. Thank you for listening.
A big round of applause. Thank you, Mr. Banerjee, for an excellent one. Thank you very much. Thank you very much.
Thank you.
Excellent. You're
Thank you.
loud and clear. We enjoyed and we learned something, many things out of it. We'll be in touch with you. Thank you very much, Mr. Jain, Mr. Banerjee.
Thank you. Thank you. I'll take your leave.
Thank you. Thank you very much. Thank you. Thank you. A big round of applause once again. Really, we could hear. Now it's a pleasure to welcome Mr. Arunava Banerjee. He is the Chief Operating Officer of Primetals Technologies India Private Limited. After he completed his Bachelor of Engineering in Metallurgy from REC Durgapur, Arunava had started his career in steel making operation at ISCO, Burnpur in 1993. He moved to M.N. Dastur and Company to serve in steel plant consultancy business in 1996. There he was a manager responsible for steel plant engineering and project management related to activities. In 2004, he moved to VI Engineering and Automation as a general manager, sales and proposal for steel making and casting business. After Siemens purchased VAI Technologies AG in July 2005. VAI became Siemens VAI and then Metals Technology Siemens Limited, where he was actively involved to get and execute projects of several integrated steel plants for public and private sectors. He joined Saporji Palanji and Company Limited, EPC division as Vice President and Head of Metals Division in 2013. He had returned to Prime Metals Limited, Prime Minister Technology India Private Limited, erstwhile Metal Technology of Siemens Limited in 2015 as Senior Vice President and Head of Iron Making, Steel Making, Environmental Technology, Long Rolling Business. He was promoted at Executive Vice President in 2019. From 2024, he took over the role of Chief Operating Officer of the company. I can go on, but with a small brief, I request Arunava to make his address, please. A big round of applause for Arunava.
So, good morning, all delegates. This is my second successive year in this conference. Thank you. Thank you for inviting Prime Metals. I think we have significant presence in this conference. The topic is contemporary, as the organizers told. Last time I remember it was sustainable steel, green steel. And this time it is artificial intelligence and cost-effective steel making. It's not a pure metallurgical topic, so excuse me for my ignorance in some of the areas. But before I start, I would like to thanks Mr. Jayanta Banerjee. I think this was quite interesting. I also never knew about so much of history in the artificial intelligence, but it's good to know. And yes, in Prime Metals, we are using artificial intelligence, and this is going on, and I think it will increase in the coming days significantly more. I will briefly touch upon, and just to because we have another presentation from one of our colleagues, Anup. He will make a detailed presentation. But I will like to give you some insights focused on steel making, not on a general level. I will touch upon the overall industry context in terms of, I am talking about steel making industry, the technological applications, the drawbacks, the impact and benefits. Some examples, very brief examples, how we are using artificial intelligence and digital technology in Prime Metals. Some, implementation way ahead, some guidelines, and a short future outlook and conclusion. AI itself is so vast, as Mr. Banerjee told, we do not know how it will end up, but let us see how it evolves. We are talking here in this seminar, the topic is sustainable steel and cost-effective steel making, how AI and other tools are impacting it. What do we mean by sustainable steel? Which is very, I think several rounds of seminars and conferences and papers have been published, but in a very short way we can say sustainability means, recycling, zero waste steel making, low energy consumption, less CO2 emission, and also encompassing all this, the overall pressure of a steel making plant to be more competitive in terms of the process, the reduction of OPEX, reduction of CAPEX. And also you have to understand, sustainable steel making is preferable, but it is challenged because there is a high cost of energy. And there is a huge market competitive pressure. So all this put together, there is, if you see, sustainable steel making and cost effective, the topic here, sometimes it can be a little bit, contradictory in nature. Sustainable may not always means cost effective, but on an overall basis, I think on sustainable and cost effective steel making, AI and other digital solutions are making huge impact, okay? And prime metals, we have a lot of examples and portfolios, but I will come back to it, in a brief manner. What are the areas where in prime metals, we are using artificial intelligence and other digital technologies? One of them is quite relevant and prevalent now, predictive maintenance. And another one is process optimization, then defect detection and burden mix optimization. So these are all, we have our established portfolio here, and we have some references. And I can tell you from customer side, the response is also slowly increasing. It is not that, we are able to make huge references with all this, but this is in the market. And what we feel, there is slowly, there is customer demand growing up. Complementary to these artificial intelligence usage, there are complementary tools which are required, this is simply not enough, the artificial use of artificial intelligence. The complementary digital tools what we are using for our prime metals portfolios are, of course, IoT sensors monitoring. We have digital twin technology, which is very interesting, where we are making a complete replica of the process unit. We are not able to do the process simulation there, but at least the mechanically, the operation simulation can be done. Interesting, in India, one of our customers, they had, we are having discussion for such digital twin for a blast furnace. We have robotic automation, we have a lot of robotic equipments where we are using robotic automation. And of course, last but not the least, the generative artificial intelligence, which we are using, for supporting our calculation models. As you know, steel making is a very rough and tough area, and we are handling big pieces and high temperature, heavy loads. So we were just discussing, it is very prudent and important that, before we completely switch over to 100% automation, it has to be controlled and monitored manually also with experts. We have not reached to the stage for complete, independency. The outcomes, I will briefly touch upon the outcomes. We have been able to see that, using these portfolios, what I told, we are able to definitely impact the CO2 emissions. energy savings, recycling and waste management increase, and of course emission impact. Basically, I am talking here about the stack emission and also the work zone emission, which are so important for the Indian context. Economic advantages, of course, if you are able to touch upon, if you can lower the energy, if you are, of course, there is a cost reduction. We are able to impact the operational, aid the operational inefficiencies, so there is an increase in the throughput and yield. And of course, the plant availability is also impacted by, all this predictive maintenance and all these stuffs which we are already selling in the market. Major issues. This, I think, Mr. Banerjee also, Jayanta Banerjee also touched upon. I think there is a big hype, but we have to be careful here. And from Primetal's perspective, I can tell you, we have in several areas we are using artificial intelligence. But like for example, for process optimization, we are using artificial intelligence, but we are doing it parallelly. That means the metallurgical model, along with that parallelly, the AI is used to really, calibrate the data and take a judicial decision. So what are the major issues? Of course, there is a cost issue. There is a, normal for any new technology, there is a human bottleneck issue, adaptability. Of course, the quality of data. I think this is one of the big issue for our all existing steel plant, and especially for India. I think the data, the correctness of the data, and not only correctness, I think the availability of the data. Even for our level 2 model, sometimes, we do not get the right data, and the data are not real time. So I think data, the correctness of the data and the availability of data is very, very important. And of course, how does it look like, in future, with the use of more digital technology and artificial intelligence together, I think we are looking for some amount of reduction in manpower at some level. So there could be, some, issues related to job loss. And of course, the last one, we cannot fully trust unless it is well established. So there has to be some human intervention till such time it is fully established. Let us talk about the examples what we have in Primetals, for operational excellence. Some examples what I have taken out, there are many, I just took out some of them, So for enhancing process, we have the blast furnace expert system, which is able to control the blast temperature, and it is directly impacting also, it is helping to reduce the coke rate and the raft control of the raceway adiabatic flame temperature. Hot metal, prediction of hot metal temperature and silicon. This is another model which we are using now, and because the normal metallurgical model has certain, this is a polynomial function, and if there are some errors, the deviation is huge. So we are using, and we have been able to use it in a very, we have got good results, I can tell you, with the AI model what we have, what we are offering in the market now for hot metal temperature and silicon prediction. Similarly, for sinter, we have also an expert system which is able to reduce the fuel. It is able to control the bed permeability. Also, it can predict the FeO content, which is directly impacting the coke breeze consumption in sinter. So, this is also AI-based model, and we have got good results. continuing on the operational excellence, we have AI-based tools for, coil tracking for hot strip mills. Also, for waste reduction efficiency, this is also, there are AI-based tools. And some of these are already, we have few references for this. I will not go into detail. Anup will have some more slides on this. And the third one, this is digital services and analytics for operational excellence. So this is mainly for our metallurgical services business. We have several packages here. We call it, we have MDoc. For our recent inquiries in public sector, they are also asking for MDoc, M-Connect, M-Predict. So basically, this is, you can imagine slowly we are going for a transformation in the steel plant, a lot of sensors in all the moving equipment, a lot of information on the performance of the equipment. And these data are, evaluated, analyzed, and if the evaluation says that the performance is beyond certain threshold limit, there is an alarm. There is also based on the package, there could be some expert advice how to solve it. So basically, we are talking here about an analogy could be a human, a person with a pathological center, both together combined, so that you are never falling sick. Any issue, all the problems, immediately you do the test and you get the right advice to really rectify it. So basically, here we are, having, we call it M-Space e-services, like MAT, this is maintenance and asset technology. This is again a intelligent asset management technology. We have some references, 2 references in India where it has been implemented for caster maintenance, where, in real-time basis we are monitoring the repaired equipment, the life cycle of the new equipment, and we are planning replacement, planning repair in advance without waiting for any failure. So this is quite effective, and the results have been quite good, because all these contracts are cost per ton contracts, so you can understand quite challenging. Yeah, okay. How much more time? 3, 4 minutes? Okay. So, then there is metal business intelligence. This is also very interesting for all, for steel plant process optimization. We have a complete solution of heat cloning and, doing this. Heat cloning is, identifying some very specific heat from a pool of data which is identical to the one which we require. And then based on those data, using artificial intelligence, finding out the right solution, how to make this heat in a proper manner. So, there are, I think that I don't want to go into detail, but basic idea is, in metal business intelligence, we are using artificial intelligence here, and the solution is well proven, and it gives a complete, process optimization for a complete steel plant. I am talking about from raw material to the finished steel. Implementation strategy, this is how we feel can be implemented, identified high impact cases, building digital infrastructure, as Mr. Banerjee was telling in his first address, of course training people, and then trying to first do it in some pilot projects. The future direction, of course, along with artificial intelligence, 5G, edge computing, and also the, it is getting stimulated by green steel initiatives, the sustainability demand. So all this put together, I think, this is in the right place for, for further exploration and improvement. Conclusion, we are expecting transformation through artificial intelligence, essential technology adoptions like digital technology along with, enhancement of data transparency and innovation and continuous improvement. So we see in primatals, a lot of potential for improvement using digital technologies and artificial intelligence. Thanks a lot.
Yeah. Thank you, Mr. Banerjee, for excellent technical presentation. A big round of applause once again from the public, please. So now it is my pleasure to welcome my very favorite Dinesh Shastri. Yeah, he is there. So I'll just give very brief about Dinesh. Mr. Dinesh Shastri currently serves as the Managing Director of TM International Logistics Limited, popularly known as TMILL, bringing over 35 years of expertise and leadership to Tata Steel, a mining engineer from IIT Kharagpur. Mr. Shastri's career with Tata Steel began in 1989, and he rose to the ranks across the diverse functions, including mining operations, logistics, marketing, and sales. His strategic acumen led to his appointment as Managing Director at Tata Steel Joint Venture in Thailand in 2004, followed by leadership roles such as Executive in charge of the Ferroalloys and Minerals Division as General Manager, Global Minerals. In 2004, Mr. Shastri was seconded to Singapore as the Managing Director of Tata NYK Shipping Pte. Limited, which plays a key role in strengthening global shipping operations. Upon his return in 2019, he was appointed as the Chief of Group Shipping at Tata Steel, overseeing the significant international shipping strategies. Currently, he also holds the Director and Chairman of roles of the International Shipping Limited FZD ISL in Dubai and TKM Global Logistics Limited, and oversees as a Director on the board of TKM China. Mr. Shastri is widely recognized for driving transformational change and for achieving exceptional results in each leadership role. His comprehensive knowledge of both the technical and commercial aspects of business has been key to his success in steering high-performance teams, delivering operational excellence, and fostering sustainable growth. A visionary leader, has consistently demonstrated the ability to navigate complex global markets while positioning the organization he leads the forefront of the logistics and shipping industries. I can go on, but with this little, may I request Mr. Dinesh Shastri to please come up. A big round of applause for Dinesh.
Good morning, everybody. I can assure you that my speech will be shorter than the introduction that my friend Mr. Nandi Pritish have given. It's actually, I am very grateful to the organizers who are essentially my mentors and guides throughout my life, who have guided me through my natural stupidity, encouraged my natural curiosity, that despite not really being associated with steelmaking only in a peripheral way, I don't know the innards of the blast furnace or the LD. My entire experience, which is about 36 odd years already now, has been in and around the steel plant. As has been said, I've worked in the mines in raw materials. I've worked in ferroalloys. I've worked in shipping. I've worked in logistics of steel, both inbound, outbound, storage. But my association, therefore, is not something that of an expert. So my mentors, or sometimes I used to call them tormentors when when they were working for Tata Steel, they know that, what I will try to bring out is I have the advantage of not being an expert and asking very basic questions and possibly hoping to get some basic answers. Now, when we talk about sustainable steel making, It's, by definition, we are talking about an oxymoron. Steel making cannot be sustainable in the true sense of the word. So when we are saying sustainable steel making, we are essentially saying how can we make the steel making more green than it is today, and how can we offset the impact of whatever we are doing damage to the environment by doing alternative mechanisms of promoting green initiatives. And where we come in is basically in the scope 2 of this, or scope 3 of steel making, in my role as logistics, where how we can ensure that the material that is required to make steel is delivered to the steel plants in a reliable and a fast way, but at the same time in the most efficient green way. And simultaneously, the finished goods are transported and delivered across the supply chain in a manner which is the most economical. So there we have worked on, obviously we all know that if you are traveling a certain distance of time across different routes, so by simple law of mechanics, we know that waterway is more carbon neutral than, say, or carbon efficient than rail, and rail is more carbon efficient than road. And the essence has been, therefore, in our, from the logistics perspective, is how to change the model of transportation and making it the best. See, road transportation can never be avoided. The first mile and the last mile invariably is road. So how to make the road transportations, we have all talked about EV as a solution, we have talked about hybrid as a solution, but as the Toyota chairman has rightly said, EV in the life cycle analysis may not be as good as what it is being touted about. So there is a challenge there. So any movement of material by definition is not sustainable. Secondly, when we talk about replacement of trucks or road movement, when we talk about railway, we have been on the forefront of railway transportation, and I'm proud to say that the company now I'm associated with is probably the largest private rail transporter in the bulk sector. We run about 108 rakes and about 6,500 wagons, and we have substantially reduced the road quotient of steel transportation in Tata Steel, as well as in cement sector. We are now, of course, active with other steel manufacturers as well. So that is another area. And finally, when we talk about ocean transportation, going forward, as the steel industry matures further and we move towards the secondary route of steel making, the impact of global transportation is expected to come down. But we today have iron ore moving from Brazil as far as to China, and coal from Australia to wherever else. Now, as this industry evolves with time, it's expected that the share of the BOF or the traditional steel making is going to come down. And with that, also the logistics requirements of steel will be also coming down, because scrap works only where the scrap is locally available. So going forward, small steps are being made in India as well, but going forward, there is a good scope that we will be able to reduce the steel making and make it slightly more sustainable by reducing the mix of steel making between the traditional route and the secondary route. And finally, but when we talk about AI, in logistics or in anywhere else, I really appreciated the point that Jayanta made a little earlier, that are we replacing one devil by another? If you are too much focused on all the new fangled ideas like cryptocurrencies, blockchain, etc., essentially extremely energy guzzling. So if we are trying to say that, okay, something which contributes 15% will be replaced by 5%, then are we looking at the right solutions? So steps today where we are looking at we are much more conservative, which we are not looking that far forward. We are right now looking at how to use big data and how to use automation as mechanisms to make our supply chain more and more sustainable. If we are able, right now, suppose I give you the example of the 108 rigs, they are flying all over the country, and even if they stop anywhere for 1 hour, we are actually reducing the efficiency, and thereby, by indirectly increasing the carbon impact. So the aim of our organization is to make sure that we track around the clock, 24/7, all across the world. So tracking and managing the data is where we are today. And I think at this point of time, these are the steps that would help us achieve a slightly better or rather more sustainable logistics in steelmaking. And with this, I would like to conclude and say thanks again to the organizers for giving me all the love and affection. And my role here is mostly to provide comic relief. Today, I could not provide that as much as well, but I'll end by saying, asking you to remember a famous Rajesh Khanna song, Main Shayar Badnaam. I will not sing it, don't worry. The song goes, ki Main Shayar Badnaam, Main To Chala. Steel industry is only Badnaam, but steel industry is not going anywhere. What we need is a sustainable society as much as a sustainable steel industry. And if you reduce the mindless consumption that goes around all of us, if every item of consumer goods has achieved the highest ever records post the GST last month, whether it's cars, white goods. Now, this society needs to be looking at themselves with more introspection rather than identifying and labeling certain industries as non-sustainable. With that thought, I leave you. Thank you so much.
Thank you, Dinesh, for the excellent message. And you said that your is not relevant, but yeah, if you see there is a cost effectiveness in this, and your logistics plays a major part in cost effectiveness of steel making. Thank you once again, Dinesh. And now I'll move on to and request our keynote speaker, for which we are waiting for, Dr. Debashish Bhattacharjee. I'm really thankful to him. He was away from Calcutta. He came for a day only for this, and he's again leaving tomorrow. And before I hand over to Debashish, my pleasure to give a few, although everybody knows him. He is an exemplary technocrat and a researcher of international repute. Dr. Debashish Bhattacharjee is a respected leader in the materials and manufacturing industry. He is among a handful of technologists who easily span the width of technology development from ideation to commercialization. Dr. Bhattacharjee is an expert in translating research into applications. Dr. Bhattacharjee has an impressive educational background. He topped his class both in bachelor's from Jadavpur University and master's in IIT Kanpur. Jadavpur University awarded him the Best All-Rounder Graduate Medal for his combined academic and co-curricular proficiency. He won the prestigious Cambridge Nehru Scholarship for PhD at Cambridge University. Subsequently, he carried out 2 postdoctoral stints, one at the Rolls-Royce University Technology Center at Cambridge and the other at the University of Birmingham. He is also an international fellow of the Royal Academy of Engineering. Now, I shall give you a very recent incident. As you all know, critical minerals has been identified as one of the top strategies areas between UK and India. Institution of Critical Metals and Industry, Guild, was announced by the Prime Minister of India and UK yesterday, that is 9th of October. This was formulated in UK-India Industry Academia Roundtable on the day before yesterday, that was on 8th of October. And that meeting was chaired by no other than our Dr. Debashish Bhattacharjee in the presence of Mr. Peter Kyle, Minister of Trade and Industry of UK. A big round of applause. Thank you very much. As you know, he is an investor now as managing partner, Leonstead Ventures, and professor of practice at the IITM. And we are proud to say and honored to have him as the Chief Advisor, Technology and Sustainability of SteelTech. With this, I can continue with this brief. May I request Debashish, please give his address. As I mentioned, I always learn something new when he says. Thank you, Debashish, for your kind presence. You made it really, Please come.
Thank you, Pratisha, for the kind introduction. Usually there are dignitaries on the dais, and you start by saying good morning and acknowledge the dignitaries on the dais and off the dais, but there are no dignitaries on the dais today. So my greetings to the dignitaries off the dais and all the participants. A very good morning. It's still good morning? Yes. I start when I should be ending. So this was the end of the session, but the organizers are kind enough to let me speak. So, but thank you for inviting me, and it's a great pleasure. AI is not my core strength, but AI is everywhere. Bit like what Jayanta said. I was a colleague of his when I was in Tata Steel, and also it alluded to by all the other speakers. AI is everywhere. There are very few people who don't use ChatGPT today. Everyone uses ChatGPT, right? I'm sure you do. Not only we use a ChatGPT for the simple letters and notes, etc. Students, I'm sure you would verify the students rampantly use ChatGPT for answers and essays and giving. Quite often it is wrong, yes. But I'm also told that teachers use ChatGPT for setting questions. You didn't know that, yes. But that's not all of it. Like, the development in computers has happened not because the academics and industrial people use computers for computation and in industrial applications. The development in computers following Moore's law, that is doubling of power and halving of cost every 2 years, has happened because of games. Because the people who play computer games, they keep demanding more and more performance from cheaper and cheaper computers. Similarly, the development of AI is really happening because people want to write notes. They want to do mundane things, and chat GPTs of the world, that will drive AI, and that is still driving AI. Somewhere in the tail, we will have industry using AI. But that is where it is perhaps of most use to humanity. So my brush with AI came in 1996. I had just entered Tata Steel with background in fracture mechanics. So I had absolutely no background in computation. And really, Tata Steel didn't know where to place me in R&D. So they placed me in a group called modeling group. Without me having any background in modeling, they thought people who are coming from abroad should be placed in some respectable sounding group, so mathematical modeling group. And most of the people were working on finite element methods and fluid flow, etc., computational fluid flow. I had no background on that. So I thought, let me start something new. So I would sit in these meetings on processes and blast furnace processes, sinter processes, and there would be interminable discussions on what caused high cost in sinter, what caused lower quality of coke, why is the hot metal silicon suddenly shooting up, why is the hot metal temperature suddenly going so low, and these were interminable. And invariably, the quality department, it was then called metallurgical department, would come up with a graph. A graph 2 by 2, 1 by 1, X and Y axis, because that's the best we could do at that time. Right? On one axis would be the output which is, say, the sinter strength. Right? On Y axis would be one of the control variables, maybe coke amount, maybe CO, lime or whatever. And invariably, you'll get a cloud of points. and somebody would draw a straight line through that crowd of points with an R square of maybe 0.3, and then say, look, there is a correlation, so we should change CO2 in this, lime in this manner, or we should change coke rate in this manner. I'm sure everyone has done that, whoever has been into process control. The fact is, there is some truth in it, and it is not true. Because in metallurgical processes, there is never a single parameter direct correlation with the output. If you look at a sinter plant result, which is strength of sinter, it will depend on the ignition hood temperature, it will depend on the chemistry of the mix, it will depend on how much coke grease you have used, and so on and so forth. But if you just do a XY plot, you're not going to capture any of those. So you'll not get an accurate prediction, and every week you'll come and have the same discussion. Because you'll change the lime, but something else will happen with the coke breeze rate. All these also have interdependency. So if you increase lime, you may have to also increase ignition hood temperature, and therefore you have to also increase coke breeze. But there may be some other route by which you can reduce the cost and reduce the lime and have another effect. Humanly, it is not possible to capture visibly or even in an equation all these variables in a systematic manner. You can have multifunctional complex equations, but you'll have to you have to fiddle with the indices and the powers of various factors in a completely arbitrary manner. There is actually no fundamental physics and chemistry that goes into it. It's all observation-based. Now, so we thought we were new, so we could think afresh. You know, if in 1960s somebody could land man on moon without trial, there was no pilot that went to the moon with a pilot man and said, okay, this pilot will be successful, may or may not be, and then we'll send Neil Armstrong. Neil Armstrong was the pilot. It either succeeded or he died. But it succeeded. So if that could happen successfully, why 30 years later we can't predict hot metal temperature accurately from blast furnaces? So that was the challenge we took ourselves. We were educated in the 1980s, so we didn't have Python. We had Fortran. So we were armed with Fortran. And we wrote an artificial neural network code ourselves. And went to the blast furnace operators and said, look, we are going to predict hot metal temperature for you. You're mad. You know, what are you going to do? We're going to do artificial neural networks. I said, what's that? Nobody knew what it means, and then you have to draw all those nodes and the links to the nodes. Nobody understood that. So it was said, these are mad. So somebody from R&D has come, let them do. What do you need? I said, we need nothing but your data. And it so turned out that you take all the important variables, and how do you know it is important? Because people talk about those. And you fit those in over the, feed last 6 months data into it. The first question that came up is that how do you know it is important? How do you know the data is important? So we did a survey. We went to all in the company who were known as blast furnace experts, even though they were not blast furnace experts. But enough, you are known as a blast furnace expert. So we had 20 of those. And they gave us a list of important parameters graded by them. So coke came very high up in the list, hot blast temperature, and all that. So they gave about 20. We took our data from the blast furnace and ran not ANN, we ran a very well-known program through this, which is principal component analysis. It's a statistical approach. And principal component analysis simply tells you how much information a particular parameter carries about the output. And it gave a ranking. Out of the top 12, 10 matched. So that is the power of computation. Computation that was at that time never used in blast furnaces. Now, using those 12, we went ahead and tried to predict blast furnace, hot metal temperature, hot metal coming out from the blast furnace. There was 95% accuracy. There was so much excitement, they said, okay, there's 95% accuracy, why don't you try sinter strength? So we did exactly the same to the sinter strength, and we got 95% accuracy. So there was test data and there was unseen data, fresh data. So then somebody said, why didn't you try coke strength? So we put it on, applied it to coke ovens, and it produced results on coke strength, again with 95% accuracy. So this system obviously works. This is 1997. And many people have talked about sensors. The sensors in 1997 were not as advanced, and the data capture systems were not as advanced as today's. So the next question that was asked could not be answered, which is, can you put it on our computers and can we be guided by this? Which meant that you have to take data out from level 2. Anyone, I'm sure people understand what is level 2 automation, from the level 2. But there was no level 2 at that time in some of those plants. So everything had to be handwritten. And that is where the whole thing failed. Failed in the sense it could not read real-time data. It had to be posthumous. Right? Or a group of people had to sit and continuously write, which was not feasible at that time, but it is feasible now. Right? So fast forward a bit. You've heard what Jayanta said. It is now possible to work on real-time data and predict with very high accuracy process parameters which you otherwise would have simply been lost in the cloud of points. People moved on, and the word AI became more popular than it was in 1996. People said, why don't we try to develop new alloys using AI? So we were dealing with the upstream. Now come to the extreme downstream. So if you are going to develop, say, a new high-strength steel, there are some known formulations, some of which are easy to produce, some of which are not so easy to produce. So if you train an AI or ANN program that these are my constraints, that I want to have the cost low, I want to have manganese within a certain range, I want to have my casting speed not exceeding this. I want the world's best high-strength, high-formable steel. So it will look through the data, and it is possible to predict a new alloy combination that will give you all of those. But there is a catch. And the catch is the word hallucination that Jayanta used. In this, essentially, an AI or ANN interpolates between known data points. It interpolates. It doesn't work outside the known domain. Within the interpolated, the known data points, it finds all sorts of patterns that are available. Some patterns we know from our experience. Some patterns we don't know from our experience or from our previous knowledge. Now, the AI will always throw up those patterns. So when you look at something bizarre coming out of the AI, it probably gives you a combination of alloys which you've never thought of. It's not in the literature. You'll think this is not possible. We would call it hallucination. But the AI is actually catching patterns which are possible. So not only does the AI give you possibilities that exist and enhance your existing knowledge. It also asks you to think and delve into your knowledge, and it enhances your knowledge. Unless there is mistake in the data itself, which the AI also picks up and gives you a wrong answer, right? The only way to circumvent this is to have core knowledge of the process and the product. And this is the learning that I've had over the last 30 years in application of AI in process. AI in process is extremely useful to make good predictions, reduce cost, increase efficiency, get to the right target output. But you need a qualified person with in-depth knowledge of the process to run it. Otherwise, you will not be able to use that AI appropriately to its full strength. So it is not an AI expert who should run, and I've made this point in a recent podcast with IIT Madras. It is not an AI expert who should be running a process control with AI. It is a process control, maybe a metallurgist or a process engineer who should be taught AI, well-versed in AI, to run that in the process. Because what is most important is to make sense of the patterns that are coming out. It enhances the knowledge. It also asks questions which can trigger new knowledge from the existing data. I'm aware of time. I don't want to make you miss your coffee. More than I have to, that is. The other concern with AI is, as was mentioned also by Dinesh, which is energy. Because of computation, because of the need for cooling of the data centers, it needs huge amount of energy. Last year is gone. By 2030, which is 5 years from now, driving AI will need 950 terawatt hours of power. 950 terawatt hours of power is what Japan uses in a year, roughly, give or take a few 10 terawatt hours. So you need to add a Japan worth of electric power to run AI for the world. And you have to do that every 5 years. Can you imagine what load the global electricity generation and distribution systems will face? Are we ready for that? And all that needs to be green, right? So otherwise you're increasing CO2. So AI actually increases CO2 if you don't convert all that electricity into green electricity. That's a huge challenge. The other challenge that I want to leave you with is AI, although it's very useful, and I've just given you a few examples, it interpolates between known data points. It does not extrapolate. You can make it extrapolate, but it'll be unsubstantiated, invalid. So it only interpolates within known knowledge. It does not create breakthroughs. Human progress depends on breakthroughs. AI itself is a breakthrough. It didn't come by interpolating multifunctional equations. It came when people thought beyond. So it is necessary for humans to keep using AI for making current systems more efficient and cost-effective. But it is also important for humans to work beyond AI to create breakthroughs for the next generation technologies. So I just leave you with those thoughts, and I wish the conference all the success. It's a very topical conference, and I hope the next speakers will elaborate on the subject with their experiences. Thank you for listening to me, and thank you for having me here.
Thank you very much, Debashish, for an excellent speech. And thank you very much for making it to this conference in spite of a so busy schedule. You are not here. You came only for this conference. Tomorrow you are leaving. With this, may I now request Mr. A.K. Sarkar, our Steel Tech person, to kindly give a vote of thanks.
Good morning to everybody. I have been told to offer vote of thanks to the speakers, but before that, I want to tell my mind to the august audience. I am a veteran in steel industry. I have seen steel industry from my younger days when my father used to work in Indian Iron and Steel Company. We have seen Bismarck converters, we have seen open earth furnaces, and there we have seen a class of specialists who used to take the hot metal from the heart of the furnace through a small bowel, and they used to see the temperature in eye only, and then decide whether the furnace has to be tapped or not. So that was the kind of expertise that we had in the earlier days, and today we are talking about AI. So this is a huge transformation. But my only submission is that in steel industry, our country has been one of the very primitive players. But the developments which have taken place elsewhere in Japan or in Germany or in US or in UK, we have not been able to master that technology even till now. We have an opportunity in AI where we can lead the whole world, where our experts can show the whole world how AI can be utilized in the best way possible, and we are, I think, on the correct path. So this seminar organized by Steel Tech, I think is a very timely intervention in the path of, in the journey of steel making in India. So I would thank the speakers. Firstly, Mr. Jayanta Banerjee, who has spoken offline, and he has given an insight about all the aspects of AI, which we were not really knowing. It is eye-opener. I thank Mr. Arunava Banerjee, Chief Operating Officer of Primetal Technologies, and he has given a total perspective of in what way Primetals has been intervening into the steel making world through AI technology. I very gratefully acknowledge what Mr. Dinesh Shastri has told us about his experience, though he was not in the mainstream of steel making, but his services to the industry has been equally important, and he has given his insights as to how to go ahead in this line. Lastly, Dr. Debashish Bhattacharjee, I'm so impressed with his speech whenever he speaks, and it has given us immense pride about his role in the international arena also. So with his message that we have got, how to go ahead with it, and how we can assimilate the human intelligence along with the AI, and also the importance of data in getting the correct results of AI. So I would expect that this seminar will show us more avenues for going ahead in this particular perspective. And our honored guests and participants will gain much out of this seminar. And let this have a seed that will be sowed for the future of the steel industry of India. And I will not be there. I am already 78 years old. We will not be there to see what all developments are taking place, but I sincerely pray that India leads the world. India leads the world in this. Thank you so much.
Thank you, Mr. Sarkar. Uh, Now we are getting ready for the panel discussion. May I request people to Mr. I'll announce the names. Mr. I think if you break again, it will be delayed. We can, in between, we'll just start it. Mr. Amitabh Ghosh, chairman of this session. Mr. Praveen Chaturvedi, in this time, please prepare the stage. And Mr. Sushim Banerjee, Mr. S.K. Nandi from Naknan, Mr. T.S. Palit, MD Fibs, Mr. Bishwajit Dotto, CEO of Arcelor Mittal Design Center, Mr. Mr. Shankar Chaudhary. I think these people are here. May I request to come in before the stage makes it, may I request Mr. Arunava Banerjee, Mr. Dinesh Shastri, Dr. Debashish for a group photo for this, please. Oh, Somesh is already there. Somesh Vishwas. And Subhajit. And I request Mr. BP Sarkar, is he here? To give the honor them with a small gift from our end, please. Hey. Please come. Mr. BP Sarkar, Mr. Go down. We can go down.
Hello. Hello.
Mr. Amitabh Ghosh, I think he's here. Mr. Ghosh? Mr. Ghosh, Amitabh Ghosh? So Mr. Ghosh will be chairing the session and Mr. BP Sarkar will be the moderator for this session. I'll be, of course, there for whenever the need comes. So before they start, I'd just like to give a small brief introduction of the people who will be in the panelists also, and Tata Sri is there. About Mr. Ghosh, the chairman of the session. Mr. Amitabh Ghosh is a BTech honors and MTech in civil engineering from IIT Kharagpur, AMI section B in mechanical engineering from Institute of Engineers. His work experience is a lot, but I will just mention a few of them. His professional experience in projects and products of engineering and sectors over the 4 decades. He served in the senior positions in various reputed companies such as Birla Technical Services, Senior Vice President Texmaco, President in Home Metals, Executive Director in CIMMCO, Titagar. Prior to above, he served as Braithwaite, GRC and Hindustan Motors. He has a great experience in steel sectors. He executed many turnkey projects in SAIL, Durgapur and modernization, EPC projects. Raurkela Steel Plant also at Durgapur in global consortium between Mannsmann Dimac Group Germany, TP Russia, HSCL and BTS. At Raurkela in global consortium between the Mannesmann Dimac and SAC BITS Siemens. He is also involved in marketing and execution of first set of modernization and EPC in different steel plants such as Durgapur and Raurkela. I'll not go in details. I just mentioned he is also associated with 26 hydro projects of renewable energy projects like solar, wind, tidal, etc. And dredging equipment under the shipbuilding, bridge, flyovers, etc. With this small, may I request Mr. Amitabh Ghosh to please come up and chair the session, please. A big round of applause for Mr. Ghosh. And I request Mr. Praveen Chaturvedi to take seat, please. Mr. Praveen Chaturvedi. Yeah, he is the Vice President, Head of Sales Upstream in India. Mr. Sushim Banerjee. Everyone knows he is a very known face. He was the DG Instag, he was in ex-ED Sale, and he is now CEO of his IISC. Mr. S.K. Nondi, he is the founder and MD of Macnon Consultancy. Mr. T.S. Palit, Tarashankar Palit is good friend, MD of FIBS, and Mr. Bishwajit Dotto, ArcelorMittal Design Center here, is here. And Somesh Vishwas is the Chief Marketing Sales of Tata Steel. Mr. Shankar Chaudhary is the ex-CEO of Atmasco, is now self-employed. I request you to please take their seats. And without any wasting any time, please, we need to. Mike that and I request Mr. BP Sarkar, so much Vishwas. So much Dinesh and Somesh is there. Arkotun chair diye da. And I request Mr. BP Sarkar. He is our consulting editor and the chief mentor. He in fact started Steeltech with Mr. Dr. Amit Chatterjee to moderate the session. With this, may I now hand over this here to chairman and the moderator, please.
Okay, good morning and warm welcome to all of you here. We are very happy that you have a galaxy of very distinguished persons here at the dais for participating in the panel discussion. I'll just start with some 3-4 sentences. You know that we are producing, India is producing about 150 million tons of steel, but China exports more than 100 million tons of steel. So India needs to be very lowest cost producer of steel. Now, in our college in the 60s, we are told that for making iron, we require lumpy ore and imported coking coal. During the last several years, the things have changed very much. Now, even the fines, low-grade ore, iron ore, non-coking coal, fines, the technology is there to produce iron from low-grade ore, non-coking coal, fines, lumpy, everything. In fact, some of them buy lean ore, beneficiate them, and then make pellets So things are changing. In fact, coal requirement, as you know, that also may not be there in future when steel will made iron steel through hydrogen. So raw material is there where we can play with for cost reduction. Energy is another factor where renewable energy has come up very fast during last so many years. In the case of logistic, it involves a lot of cost in steel making. A lot of things are coming up, slurry pipeline, etc. I'll only request, as Dinesh Shastri has already covered, that we should not carry waste products. I think we all know about it. And another is, of course, employee cost, where cost reduction can be done, and many companies are looking into it. And lastly, but not the least, the environmental aspect, the location of the plant, what the regulations are there. Suppose this plant is in Europe, there's a lot of regulations, and it is very costly to follow all the regulations, which is of course important. So I end here. We have got people from various streams, and they will cover the various aspects of the industry. Now I request Chairman Amitabh Ghosh to start the session. Thank you.
Thank you, Vishnu, and good afternoon, good morning, everybody. At the outset, I'd like to thank SteelTech for organizing this very nice steel seminar and giving me the honor to chair the panel discussions with galaxies of very knowledgeable people. Subject of panel discussion is steel industry status, challenges and opportunities. So I feel the challenges is that we have a national steel policy 2017 to achieve 300 million ton per annum steel capacity and 160 kg per capita steel consumption by 2030. And today's situation is, it is 179.5 million ton per annum and 108 kg per capita. So we have only 4 or 5 years left, and we have to go from 180 to 300. I think this is our challenge, how to make it. And this is one. And other is, of course, that I will just mention few bullet points which I had in mind. That one is, of course, technology transfer for Atmanirbhar Bharat. Then the steel plant equipment shipped from foreign to Indian sources. Then optimization of steel quantity for equipment and steel work. Then application of artificial intelligence in steel sector. Application of AI in project management and execution. Then AI-enabled user-friendly digital solutions for design and drawing of equipment and steel work. Then maximization of use of solar and other sources of green, sustainable, renewable energy towards net zero. And then, of course, industry-focused education in technical institutions for creation of suitable human resources. And finally, association of reputed organizations like IIT and acclaimed industry experts towards mission Atmanirbhar Bharat. So I now request the renowned panelists to talk on the subject as they like, one by one. I'll first say Mr. Praveen Chaturvedi from Tinoba. Mr. Chaturvedi.
Good morning. Thank you, sir, for this wonderful the session, chairing the session, addressing the challenges. I have just noted it down some of the points. Challenges, if we ask for this steel fraternity, because as you know, we are Tenwa, the part of the Techint group. We are also the steel manufacturer in the name of Tenaris, Ternium, and also having the major stake in those Minas. So considering the challenges, the first thing will be the safety. That is also foremost important that we must address. Then energy efficiency, which Mr. BP Sarkar has already told, and the reduction of the carbon footprint. Then technological transitions, that has to be addressed. And then we should be ready for the future challenges. Challenges, when we say that what Mr. Sarkar has told, that we should be ready with whatever the raw materials are available, whether it is the coal or the pellet or the fines. So those things we have to address, and of course, the scrap. And then we should follow what the market basically needs. And without compromising on the quality, we should go for the quality steel, as we were discussing in the previous sessions about the alloy steel or super alloy steel. So those things has to be taken into consideration, and of course the productivity. Then what are the how to overcome these things? Of course, improve the existing energy efficiency, recycling, and that is the circular use of the material, modernization of the existing system, renovation improvement, that has to be taken care of, and improve the process and the practices. That is far more important. And of course, everybody is now working for the improvement of the yield, how to reduce the raw material consumption and enhance the productivity without any losses or wastage, whether it is in the terms of material or energy. So, as a way forward, small, quick, and which can be realized very soon, all those measurable things should be taken up without large investment. And of course, this can be possible with the help of the AI and digitalization, which is the topic of this discussion. Thank you.
Hello. Next is Mr. Sushim Banerjee from IISSSSC. He is the CEO. Mr. Banerjee, please.
Thank you, Chairman, and good morning, all the participants. Since morning, we had a very interesting discussion on application of AI and sustainability in steel making. And I must thank SteelTech and their team for inviting me to share my thoughts. The topic that is for the panel discussion, the challenges and opportunities for achieving 300 million ton of capacity by 2030 is very, very appropriate. And I'll just summarize my views on the few challenges and what are the opportunities that the new technologies have thrown before us. The first challenges, which I could guess, that this capacity augmentation relates and particularly crucially dependent on the market that is going to be created. So we must have a sufficient indigenous steel demand so that it can support the capacity augmentation of 300 million ton. No private entrepreneur will set up steel capacities just to have an eye with the export market, which is now in a very serious state of uncertain scenarios. So indigenous demand will be the major focus area, and that will have to make the, the environment suitable for creating that. So the challenges basically crucially hinge on how to create that market. So what I could gather from the various factors that are now creating the demand. One is the investment, that government is also coming forward. But the serious challenge is private corporate investment is coming down. It is very, very stagnant. So does it mean that the private entrepreneurs who have got huge fund available because the market, the revenue generation is quite adequate, and we are creating, good values for the product. So why they are not coming forward to invest in a manner in which, it can further promote, supplement the government investment. The government investment, there is a limitation, and government is doing that. But private corporate sector must come forward to invest appropriately so that this total investment, the total capital formation justifies the creation of capacity. That is number one. Number two, there is another factor which caters to the demand is the consumption. If you see the consumption also, the government is creating income generation by giving SOPs in the income. They have also GST rates have come down, prices are somewhat controlled, and that will also major incentive for the people to come forward and invest. So that is a number one. Number two factor, which is an opportunity and which everybody should come to exploit that, so that the demand is created. The third factor is the steel intensity of investment. Are we very much aware of that? And here, we have a feeling that steel intensity in investment is not going up because of the simple fact that some of the major steel design technologies which are available in the outside world, and they have also been much largely benefited, is not somewhat, it is a very subdued impact in Indian case. For instance, in the housing sector, the light gauge steel frame technology, which gives a lot of impetus for steel, enhancing steel intensity, is not there in our country because of the fact of, the cold form structures, which is not having a adequate, BIS norm, so that, institutional demand for, cold form structural grows up. So this is a very, very serious challenge. And if it happens, then the housing sector will be a major impetus for, enhancing the steel demand. Instead of, in Prime Minister Awas Yojana, where, only 4 kg of steel is being used per square feet, this will immediately translate into about 10 to 12 kg per square feet. So you can imagine what will be the demand from the housing sector alone will come up. We'll have to keep a very close watch on this technology to take shape in India. The second one is that, in our education system, the emphasis on, steel-related studies are not there. There is not even a single semester in the engineering courses only on steel design, which is very much required. And, there were many representation on that, but still it has not happened. I think this is a very big challenge in our case. The third one I could explain is that, the indigenization or the Atmanirbhar Bharat, which Chairman has said, is a very, very good, impact on the creation of the market. You have seen what has happened in case of tin plate, which India was a large importer, and today India is exporting tin plates, meeting the domestic demand, and domestic use of tin plate is also coming up. The same thing happens with CRGO and CRNO. India was a great importer, and now a lot of capacities are being created so that these indigenous availability is itself creating demand. Defense acquisition. India was a major importer. 65% of defense equipments were going to be import dependency. And today, within a gap of 10 years, it has come down to 35%. And a lot of opportunities for the steel-based engineering goods, defense goods are being procured. So this is a very big opportunity which we must. The last one is the skill development, where I am really associated, and I find, although the large industries, they are coming forward for this skill development, creating skilled manpower who can support this capacity augmentation by the large players, the small and medium enterprises are still hesitant to come forward for getting their people skilled. So that is another big challenge. I think government and along with the industry must come forward to bridge that gap. With that, those few ideas, I think I am ending my speech. Thank you very much.
Thank you. Thank you, Mr. Banerjee. I will now request Mr. S.K. Nandi, he is the founder and MD of Makan Consultancy. Mr. Nandi, incidentally, is my old colleague. We have done Durgapur and Rourkela steel plant modernization together. Over to Mr. Nandi.
Morning, ladies and gentlemen. I think the subject of this seminar was the application of AI in steel industry. Frankly speaking, I know very little about AI, so I would like to talk on a subject which I am very much familiar with. See, for the last 22 years, we are working on projects mostly related to the secondary sector of the steel industry. As you know, the secondary sector, they constitute about 40% of the total production of steel in India. That means in 2024, the actual production from this sector was about 60 million tons out of 150 million ton total production of the country. Now there are various problems faced by this secondary sector, and the secondary sector comprises two main areas, like the arc furnace and the induction furnace. I would like to talk about the induction furnace, which I am more familiar with. You see, induction furnace best steel plants, they are mostly having their own sponge iron plants, and they use sponge iron as the main charge in the induction furnace. Their charge mix, it constitute about 80% sponge iron and 5% scrap and about 15% of pig iron. Average yield of these furnaces varies from 83 to 84%. Power consumption is very high, about 725 to 750 units per ton, only for the furnace. And if you take the auxiliaries like casters, cranes, and other units, it comes to about 800 units per ton of steel produced. So the main problem of these induction furnace units is the quality of inputs, which in effect directly affects the quality of the steel produced. As you know that our Indian ores, particularly in the eastern region of the country, they contain high phosphorus. And this high phosphorus from the iron ore goes into the sponge iron, and from sponge iron into the liquid steel. So the phosphorus ranges from 90 to 100 points, which are very high for any good steel grades. So these units, particularly these induction furnace units, as you know that they make mostly TMT bars and wire rods. Now, these units, they have to make mostly those grades like 450, like AFE415D, AFE500, and AFE550 grades, which is not recommended for high-rise buildings, for dams, for bridges. So their products are restricted mostly to housing sectors. And the upper grades like 500D, 550D, and 600D, they are mostly made by the integrated steel plants using the conventional blast furnace and a BOF route. Now, what is the solution for making good steel? If these units are to make grades as per 1786 and higher grades, so they have to go for secondary refining. And the secondary refining like ladle furnace cost additional minimum 2,000 rupees per ton. So they become uncompetitive. So they have to go for branding and just for their, just for the sale of the products. That's why we see for most of the grades, they engage Kapil Dev, Dhoni, Virat Kohli, and Shah Rukh Khan and all these fellows. So they have to spend much more money on branding than on the improvement of the quality of steel. So, but these units, they have employed one of the most innovative technology, and which has been used, I think, first time in India only. That is the direct rolling. Now, most of the units who have their own rolling mills, they follow direct rolling. And you can say that in the old units, they had a reheating furnace, but in the new steel plants which are coming up, they are keeping a provision, very small reheating furnace for the billets which are cold. So their standard use of direct rolling is about 92%. So this 92% means a lot of savings in fuel consumptions. So, and about this electric arc furnace sector, I would like to say a few lines. There are not many electric arc furnaces now in India which are using solid charge of scrap and DRI because of the high cost of scrap. But there are some units which have gone to use the liquid charge. That means hot metal, if they have blast furnace and if they are producing hot metal, this hot metal is being used. In some units, hot metal is used up to 80 to 85%. So it is not actually an electric arc furnace, but it is a mini BOF. They have got intensive lancing facilities, and practically very little power is used for making steel. So such units are there with JSPL, JSW. JSW is one of the biggest user for this. And in some sectors like JSPL, they have also made a very, very advanced which is called flexible modular furnace, which is a combination of electric arc furnace and also BOF. And this furnace can handle all combinations of charge mix. That means solid, liquid, everything according to the availability of the raw materials. So this is, I would say that these are what are the challenges? The challenges of this secondary sector, particularly the induction furnace sector. Quality is one of the main problems. And this quality can only be met by engaging the ladle furnace or some other units for the refining of the liquid steel. With this, I end my speech. Thank you all.
Thank you, Mr. Nundi. I would now request Mr. T.S. Palit, MD of VIENS, to present his views.
Good morning, everybody. Respected chairman and other dignitaries on the stage, and also the respected participants. Myself, maybe last 4 decades involved in the industry, mainly in the implementation of the capital projects in the steel. I'm not an expert in the iron making or steel making or the processing processes of steel making and steel processing. Everybody knows that the challenges now worldwide, globally, or in India, the major challenges the industry is facing in terms of the decarbonizations, or the challenges due to overcapacity in the market, or the various fluctuation in raw material prices or energy prices, which is contributing to steel production cost, and on the other hand, the profitability is coming down due to particularly the supply demand mismatch. I will not go into all these things. I will, from the capital projects point of view, I'll just address the issues like that. The challenges which we are facing in the Indian steel industry in terms of its capacity increase in line with the call made by the government is the implementation of capital projects. In India, if all of you, if you think that maybe last 75, 80 years we have got the independence, still now we don't have in India our own very good renowned design institutes who can design the steel plants, iron making plants, or the processing lines. Okay, I am not completely telling that we don't depend upon the technology we need to bring from the age-old developed nations, European nations, or other countries from which normally we bring the technology. But so far, maybe our policymakers have never thought in that angle that we being such a big country and we are on the track of development rightly, but we don't have our own design engineering institute or our own capability. Maybe some of our Indian companies can design themselves maybe a blast furnace of maybe less than 2000 meter cube capacity. And also, if you think about any other area like steel making or casting or rolling or anywhere, our companies are coming up. There are few small companies coming up in last couple of years, those who are doing the thing, but doing the thing in a much smaller way. So whatever big investment we are doing here in India, mostly we are depending upon technology from the outside. That is number one. Our core engineering strength is not good in India. Secondly, the equipment manufacturing sector for which the plant and equipments required, most of the equipments nowadays we are doing indigenously. That is one good thing we have done in last 30, 40 years, that many things we have replaced by the Indian company. But if you see that really there is dearth of good manufacturing companies in India. Only very few, couple of companies you can name who can really produce very good quality equipment which is required for a process industry like this. And also, even if they are capable of doing that quality-wise, they will not be able to maintain the schedule because their capacity is very less. So if I go in a big way to them, they will not be able to cater. So more and more such companies to be developed. And also, there is dearth of very good renowned EPC companies. They are also very few, if you take the names, only 1, 2, 3 or 4 are available who can really make the things in a big way. So I think when we are talking about big way expansion of steel industries in India, I am not going to that angle where there is a demand in the market or that per capita steel consumption increase, how it is related with the that purchasing capacity, etc. But just in a crude way, just if you see the implementation of CapEx project in India, we are most of the cases it is delayed. So as such the profitability is very low. So if the project is delayed, the cost overrun, naturally the investment cost is more, then more pressure on the future profitability of the industry. So all these things putting together in Indian, a complex situation is there. There are multiple problems. So I only just raise these things for everybody's thinking in future, or maybe if this message goes to the policymaker, 2, 3 things I want to highlight, which I told through my speech. I think, thank you.
Thank you, Mr. Palit. I now request Mr. Vishwajit Dotto. He is the COO of ArcelorMittal Design. I'd also request the balanced speakers to limit the duration of speeches in around 5 minutes.
Thank you very much. I'll make it shorter than this, and I'll keep it at a macro level. First of all, good afternoon, everyone. Good afternoon, all the dignitaries. So, I'm fully aligned with what Palita was mentioning about various challenges. Coming to the opportunities, I have no doubt, and even the figures also suggest that there is huge opportunity as far as India is concerned for the growth. So we can expect a lot of upgradation, modification, expansion jobs coming up, including the new steel plants. But there are, if I talk about the global scenario, the challenges are much more. Because today, when we talk about the sustainability, we need to also focus on we have some commitment for the carbon neutrality within very soon. I mean, we have phase-wise implementation plan. But at the same time, there are a lot of challenges as far as the cost of production is concerned with very high capex numbers. So, and there are, of course, uneven kind of scenarios exist globally. So there are a lot of effort which is, say, from in Europe, a lot of talk is going on about the CBAM so that some level playing field is established. So going forward, I think we largely depend on our technology providers. While we take care of we are the engineering arm of ArcelorMittal. We try to take care of go for optimum solution for the engineering, but we largely depend on the technology service providers. They need to come up with solutions, focusing on the existing facilities, because it is not really very easy to migrate from the established traditional method of production to a new kind of new process. And particularly if we focus on, say, decarbonization of the blast furnace or other things, maybe our technology service providers can focus on systems, bring maturity, because no manufacturer would like to go for a change in process, which is irreversible, and if it doesn't, give result. So with this, thank you very much.
Thank you, Mr. Hatto. I will now request Mr. Shomesh Biswas, Tata Steel Chief Marketing and Sales.
Let me save some time by sitting over here.
Okay.
Thank you, Chairman, for introducing me to the panel and the audience. Am I audible? I don't know. Yeah, okay. So the topic of opportunities and challenges is quite a common topic. I've heard a number of seminars. So opportunities, as Chairman has said, it's not only 180 to 300 million tons. I would say by 2047, 500 million tons. That is a number that has been talked about for India. So it's a huge opportunity, but challenges are galore, and challenges are which are at risk actually. It's a high probability that it will happen, or we have to take care. So risk is an uncertainty, but this is nothing much of uncertainty in this. And uncertainty and challenges are across the value chain. It's not only steel, it's from raw material to logistics to demand. As Mr. Banerjee said, that light gauge structures are not being used in demand. So we are having hegemony of cement. So one of the second largest producer in the world of cement, and their RCC construction, the steel gauge construction are there. That is for the demand to the raw materials. There is a challenge in raw materials. If I come, I will touch upon a few of these main points. We all know that auctions have happened, the prices have gone haywire, the bids are so high, and the bidders are not able to operate the mines. And the policy is a challenge for the steel industry. And as we mine more from the mines, the quality of the ore is reducing, the content of sulfur, phosphorus, or silicon increasing. So it requires total beneficiation. It's not only washing. So you have to grind, you have to wash, you have to make it agglomerates. So it's the cost is not simple that you spend few washing and you can easily use that. So as a Fe percentage reduces of the ore, or the quality of the coal reduces, you have to spend more on raw material beneficiation in a way. So that's the challenge. And we don't have so much of land, for keeping the slime also. So every aspect there is a challenge. So how you beneficiate. So where to keep the slime? Where to have the forest clearances, land acquisition. So challenge is galore in each of the sectors that you talk about. Coming to the technology adoptions, we have been talking about technology, but what technology to adapt? Should be blast furnace, which has a life of 40 years. We have a decarbonization has been talking about across the globe. We have a 2070 target for India to be carbon neutral. And if it blast furnace has 40 years of life, maybe 2070 is not a static target, it will come down. There will be a lot of pressure on the government to reduce. Because 2050 we have to abide by the Paris Agreement in a way. So what type of technology to adopt? And in the adoption of technology, whether blast furnace or electric arc furnace, whether the scrap will be there available for the electric arc furnace, and we are sure that the scrap is not so available in high quantities. So yeah, iron ore will be there. So we're taking everything into consideration. The technology adoption is a huge challenge. And in that also, being in strategy for so many years, what is the spread that we talk about? Spread means steel price versus raw material price, the gap. Whether it will remain at $180, $200, it will come down in future. That's the point of view. So which will, what will the price discovery of steel going in next 10, 15 years? Because the technology adoption is investing a lot of money. So China have been the price discovery as well as the global steel player, have been exporting. It's a benchmark based on the Chinese raw material prices and the amount of say 5% profit they make or 2% profits they make or maybe some negative profit. So we can have an assumption on the global steel prices. But what will happen in future, whether China will be there or China has announced that they will reduce and cut production. Whether China will be the global steel price setter or Russia or India. We are not sure what will happen in the future. But coming on to this profitability part, this is the challenge, the financial challenge. In India, the cost of capital in banks, you give us loan at 10 to 12%. The cost of equity is 15%. The expectation is more. So the need of the business to have posting of say 18%, 20% profitability. Compared to China, the cost of capital is less than 5%. The need to post profit is much lower. So in India, once you operate a steel plant, you have to have higher profits, otherwise the banks will not give you loan. Compared to Chinese player or a European player in a way. The cost of capital, we know, in developed economies, also some few of the economies like China are quite low. So that's also a challenge. Where will you get the money? And how will I make business and make more profits? And we fight with the Chinese players. So coming to, from technology to say logistics. So from China West Coast, Southwest Coast, Southeast Coast to say Chennai, it's around $20 per ton of the ocean freight. From Jamshedpur to Chennai, so equivalent, I spent $40 rail freight. So logistics is a challenge. In going forward, so it's not only cheaper raw material, cost of production is lower, it's the total cost to serve to the customer. Okay, that is being compared of. And we are fighting it in a global market. It's not India as well. We will not be having safeguard measures for long, and it will not be there. If we assume that things, then there's a fallacy for any player for say 20, 30 or 40 years down the line. I will not take much here. So manpower is a challenge we talk about, but there are things like so much of million tons of coming out, so much engineers are required, so much of people are experience is required, but things are changing with AI. So we are say doing say digital SOPs now. So what material to move to which place? Earlier people with experience of 10 years would need to decide. Now with the click of a button, we know which material to move by when. Each day I can allocate based on the profitability of the customers, which to give material. So I need not have a 10 years experience. So manpower challenges, certain things will get mitigated by the technologies that come up. It's a very dear subject, it's a very important subject. We can talk lengths about it across sustainability, decarbonization, logistics, manpower, it's in depth. So I will not take much time because of the paucity. Thank you.
Thank you very much, Mr. Viswas. I now request Mr. Shankar Chaudhary, ex-CEO, Self-Promised ATMAST CEO.
It's not ex, I'm still the CEO of at Moscow.
Huh? Okay, yeah. CEO, sorry. Thank you.
Good afternoon, Chairman Sir, dignitaries on dais, and delegates and friends. Thanks to SteelTech for selecting eco-intelligent topic to meet the challenges and bring sustainability when India is thriving to produce 300 million ton of steel by 2030. India is facing dual challenges: cost reduction and decarbonization. Digital transformation is the strategic bridge between the competitiveness and sustainability. Industry must evolve from reactive to predictive and manual to intelligent operation. The objective of this seminar is to transform the traditional steelmaking value chain to digitally integrated, cost-efficient, and sustainable ecosystem by application of AI, machine learning, and other Industry 4 or 5 tools for a paradigm shift from an energy-intensive and emission-heavy operation. This will support India's vision for net zero steel. The basic areas where these transformations are to be applied are basically process optimization, predictive maintenance, quality and traceability, and energy and resource management. All these aspects will be dealt by the experts in their next deliberations throughout the day, so I am not focusing on these much. Next is this, what will be the sustainable benefits out of these AI applications? It is basically the CO2 tracking and carbon accounting, waste heat recovery and energy management, and supporting green steel and ESG reporting. Basically, this application is CapEx friendly, and it is also retrofit friendly. And it will improve the safety and the reliability and the reporting aspects of the steel plant performance. What is the way forward? The way forward for the industry will be establish digital learning centers, collaborate with AI startups and EPCs, and integrate data-driven decision-making system at the plant level. Since I'm being in EPC business, so for the EPC companies, my suggestions are to bridge the engineering with digital intelligence and also partnering with smart automation, predictive maintenance, and process analysis. To conclude, AI will not replace manpower, but the people who adopt AI will definitely replace who don't. So at the end, I should conclude my remark by saying that the future of the steel is not just stronger, but it is smarter, greener, and more sustainable. Thank you.
Thank you. Thank you very much. And thank you, all the panelists, for a very nice, thoughtful speeches on the subject. I think they have covered a lot of areas, but I would like to say 2 points, small points. Number one is that when we did Durgapur Steel Plant and Arcola Steel Plant modernization in 90s with global consortium, that time the importation was 20 to 25%. And during execution, we shifted, before and during execution, we shifted a lot of items from foreign to Indian sources to reduce money. In fact, in the last time, when the contract was to be finalized in 1989, we were told our value was 1900 crores, which is around 20,000 crore now. They said, unless you can reduce 150 crore, the project will be shelved. And Mr. Nandi, myself, and another gentleman, Mr. S.K. Mishra, we sat for 2 hours and we reduced. One of the main way is to shift from foreign to India and also to delete some additional frills. 150 crore was reduced and the contract was finalized. And also during execution, we continuously tried to ship from Russia and Germany to India. And they were happy to do that. And that time we thought that in the next modernization, there will be little or no requirement from foreign. But I am not seeing the same situation. My humble request to all the experts, when you can guess it will happen, that's number one. Number two, but one thing was not there, that was artificial intelligence, which is a recent thing. This is a new language of global talent. AI offers opportunity to amplify human potential from freeing people from repetitive tasks and opening opportunities for higher value contributions. It will bring speed and scale while humans bring judgment, empathy, and creativity. So human being over that artificial intelligence. But I have another point, that engineers, technocrats, and professionals in our sectors can be divided in two groups. Group one is the hardware group. Hardware group is we, with experience in product and project in engineering sectors. Group two is the software group. They are the experience in IT, digital, and maybe AI also, they know. 20 to 30 is the age of AI, I am been told. So AI offers opportunity to bridge group one and group two with effective relationship between man and machine, resulting tremendous benefits in industries and society at large. This is my thing. So we must, because the maximum experience the people, 60 plus population they have, in a knowledge level. And they can combine with the youngest people, 20 to 30 age group, and do the application of AI in our agriculture. One example I'll give, the project status report. This is a thing every day we need in an ongoing project or the new project. And you will always see there are 2 to 3 level of information comes. One for the top, one for the, and one for the actual people. They will say, actually it will not happen, but we cannot say it will happen. So we are saying, yes, sir. I said that we can have AI-generated figure, which will be same, chairman to chaprashi. Everybody should have the same figure. And because there is no reason to be hypocrites. If it is not, if it has not happened, we should try to make it up. So that's the way I have seen, I have worked with management DMAC group. They used to say that never do this. You take contingency, but once you give a date, it should not slip. This is so I feel that with AI, we can do a lot of things. Another thing is, with drone, with the support of drone, we can visually show the project situation in a conference room, which was not possible earlier. This is the. So with this thing, and another gentleman said about design institute, is absolutely correct. If you see design institute concept, we have taken from Russia to some extent, but we are not totally successful. China has taken very effective. Those design institutes later on became EPC contractor also, like EIL, Mekon to some extent. Very, very successful there. So I think we should follow that. And then last point I should say, today there is a political support and willingness. Of course, there was always there, but today we say it is there. But there is a responsibility for the technocrats also to come forward and make a group and make presentation to the politicians also, that yes, we can do it. It is not that when they will say, I will run, which happens usually. So thank you very much, and thank you very much, Steeltake, for giving us the opportunity to speak freely.
So thank you all the speakers and Chairman Mr. Ghosh. It was really challenging for Mr. Ghosh that the time which was given originally 1.5 hours, it has to be squeezed to 1 hour, and he is well within that time. We have finished almost at 12:30 and covered, I think, all aspects.
So we had good time management.
Yes, sure. Okay. And as everybody said, AI, whether we like it or not, it will be there in everywhere. Especially I can see in the social media, it has come very much. Sometimes it is fake, sometimes it is true, but it's already we see everywhere. Whenever we use smartphone, we find the application of AI. So it will be there in the industry as well as in our life. So thanks everybody. Ritesh.
Thank you very much, Chairman Sir, Mr. Amitabh Ghosh and Mr. BP Sarkar, moderator, concluding it very nice, panel discussion. A big round of applause for them. We may go for a photograph, please. A group photograph. If you stand there, you can stand there. Sure. Yeah, whereas fast. And once you take the photograph, thereafter I'll request Professor Siddhartha Das also to honor them. Come to me, Cholis. Thank you. Be there. Thank you very much, everyone. We are now going for a technical session 1. So I request our team to prepare for the stage. Shubhajit, I think there are 5 people now. Professor Sen, Professor P.K. Sen, former Professor IIT Kharagpur, Mr. Tushar Chakraborty, Director Deloitte, he has come, and Nicolas, I met him, Nicolas VIENS. We request you to please take your seat, please. Mr. Chakraborty, Tushar Chakraborty, Nicolas, then Mr. Praveen Chaturvedi to please come to the stage, and Mr. Anup Kumar Kedia. Anup Kumar Kedia. We request all the speakers, and if you see that please check your presentations to be that here in the one. I think Tushar will be giving on the laptop, and others please take the console and test their presentation if it is there. So,
good afternoon to all of you. I am very privileged to be associated with this session, which in fact will be a learning experience for me on AI applications. Let me just introduce this session. It is interesting to note that AI applications are basically found in 4 areas. Now, that is my own R&D. What I found is that you have regime technologies that are highly focused, and we have some AI applications, not really many, about 7%. Niche low-carbon technologies, around 2% or 3%. Regime technologies, common for all steel-making pathways, that's about 50%. Now, look into this. And the last is technologies and functions, which are other than processing, that's the balance. So what does it show? It shows that AI indeed generates short-term sustainability, please mark my words, and benefits in the sectoral case. It feeds into steel industry's existing path dependencies and technological trajectories, because that is where the companies make money. Depending on the size of this lock-in effect, future research direction has to grow further. So there is a lock-in effect which is visible. Now, that is not all. As against the present direction set by AI, we need to mention about the Indian policy perspectives, which has now come out in the form of a big document, which almost all of us have read. Now, the Indian policy perspectives need to be aligned to future AI applications. That is my humble request. What does this document contain? You would have read it. It contains strategies for transition, green taxonomy, that is pulling down the emissions from about 2.54 to 2.4. There are four of these which have been announced, and suggested technology pathways in which hydrogen energy management features quite importantly. We'll talk about, somebody hopefully will, primatals particularly, might talk about high-4 and high-rex, but there are enough things to do there because AI can predict hydrogen demand in DRI prediction. That is what I think. It has not been done, but it should be done. Now, with this brief introduction, let us now get on to business. We have about 4 presentations here. I would request about 15 to 20 minutes for each presenter. The discussions can be held afterwards, during lunchtime. And we will commence with, I think the first presentation is Mr. Tushar Chakraborty, who is the director with Deloitte India, having more than 20 years of experience in metal sector, in strategy and operations, and who has also now been instrumental in driving multiple strategic discussions with leading miners, ministries, and policymakers. So, Mr. Chakraborty, please.
Sorry for the initial technical glitch. That's the flip side of technology as such. Okay, yeah, it has come. Fantastic. So, till I have the privilege, no, I don't have the privilege to say good morning. It's good afternoon, everyone. This is Tushar Chakraborty. I'm an executive director with Deloitte. And the next 10 to 15 minutes, I'm going to talk about, or rather justify the topic which has been taken up by Steeltech. Thanks for inviting me. That is automation, digitalization, and technology integration for the Indian mining and metal, or rather steel sector. So, well, before starting this presentation, let me start with, I would say, kind of a disclaimer, which says that future is not predictable, but we can identify the important drivers that will shape the future. So the moment we predict future, we are God, but we cannot do that. As analysts, as people who are there in the industry, what we do is we typically look at those drivers. And there are 5 major drivers who are driving this entire set of things which are happening around us. What are they? Society, technology, environment, economy, politics. So if we talk about these 5 key drivers or 5 key buckets, we see that all the initiatives which are happening in and around us, you can fit in one of those buckets. Example, if we talk about biotechnology, if we talk about artificial intelligence, if we talk about, maybe something like competition for talent, maybe DIY movement, mass migration, every such kind of initiative which is happening in and around you, which you see in media, which you see in any such platform, can be bucketized in one of these places. And if you typically look at the major trend which is happening today is something which is around technology. So most of this can be bucketized in technology, and that's why technology has become the future. Whatever we are talking today, or whatever we have probably witnessed over the last 20 years, people say future is digital. No, future is not digital. All of us, all the millennials, all the people sitting in this room, we have already witnessed that digital change over the last 20, 25 years. When we started growing, I'm just parking the Gen Zs for the time being, and considering most of us are millennials or above, so we have seen that transformation in the industry. We have seen that how computers came. We have seen how the industrial revolutions happened. We have seen how industrial revolution in the form of digital era has already hit the market. So this entire transformation which has happened is something which is very important if we consider what is happening in the market today. So how do we look at the future? The future can be again customized or rather looked at in 4 key segments. The first is future of manufacturing. Most of us in this particular seminar are representing maybe manufacturing industry. So the manufacturing industry is getting into the automation side. That is the kind of movement which is happening in this industry. IoT is something which you are hearing everywhere. And the third is connected supply chain. Previous speakers were talking about some of the logistics issues, some of the issues which are happening in the industry. You can connect everything with the future of manufacturing. Similarly, the next bucket is future of work. When I say future of work, the most important aspect here is connected people. Today, most of the industries are working on WhatsApp. The morning communication over WhatsApp from the manager to the senior manager or to the CGM and everybody is something which is official or unofficial way of communication which has happened. Just consider there was a day in between when WhatsApp was, I think there were some issues, some technical glitches. You have seen how the world stopped. There were Indigo flights which were cancelled because of some threat somewhere. So all these things are happening, but then the point is, it is very important to address and appreciate the point that everything is about connected people. The third is future of digital. And why future of digital? Because digital itself is a subjective word. There are a lot of things which gets into the depth when you talk about digital. Anything and everything happening around us, even this mic is a digital initiative because the way we are communicating. So digital has multiple depth. So at what depth we are looking at it and what are the kind of benefits which we are going to get out of it is another set which is going to be very important. That's future of digital. And the last, which I consider to be the most important, is future of data. And why so? Because, ladies and gentlemen, let me give you one figure. Last 3 years has produced, in the history of mankind, equivalent set of data, or rather, not even last 3 years, last 2 years, has produced or created equivalent set of data which has been developed over the entire mankind. That's the kind of data we are producing today. That's the kind of data we are producing today. So, and the rate of adoption, that's another very interesting thing because the way we used to look at this earlier versus how we are looking at it today, again, is something which is to be looked at very carefully. Because let me give that with one very classic example. That's called speed of adoption. You know how much time Netflix took to get the first 1 million customer? They took 3.5 years. I mean, Facebook took 10 months, and that was year 2004. And similarly, Spotify, almost all of us are using that, took 5 months. Let me throw this question to all of you. How much time did ChatGPT took, which came in 2022? Or per se threads? Okay, I'll not keep a suspense here. ChatGPT took 5 days to get 1 million customer, and threads took 1 hour to get 1 million customer. And that happened in 2023. We are in 2025. Just imagine, and in fact, I have n number of lists between 2023 and today. The rate of penetration in the market, the rate of adoption, it has multiplied like exponentially. So it's important for us to address this fact that we are witnessing AI, we are witnessing technology, and this is not something which is past, this is present, and this is future. So with that, let me try to customize certain things for you and start with what is happening in the value chain, the steel value chain, globally and India. What are the key themes which has come out here. The first is, of course, digital physical transformation. We all hear about IT-OT integrations. We all hear about IT-OT conversions, digital twins, simulations. Every word which is mentioned in this particular slide as key technology enabler is something which you have heard somewhere. But the themes are, first, digital physical transformation. The second is digitally enabled connected workforce. I just talked about it. Integrated enterprise and ecosystem, very important element. And the fourth is next generation analytics and decision support. Again, ladies and gentlemen, we are not in AI. We have moved to agents, AI agents. And what is exactly AI agents versus AI versus Gen AI? AI was the initial transformation when there was some simulation happening like humans. When we talked about Gen AI, the text, the visuals, they were developed. And now we talk about AI agents or agentic AI. Agentic AI is the one who is capable of taking decision like humans. When they look at the trend, they start taking decisions. So we are already in that era when the AI has moved to AI agents. And sooner or later, you will see the robots and Sophia. You must have heard about Sophia. So all these things are something which is happening in and around us. So how does that impact the industry? Where are we as steel producers, as people from the manufacturing unit? Where are we? So let me give you a feel of where are we. Look at this graph on the right side of this particular slide. You will see that when I look at the total integration around major digital technologies implemented in the steel industry, 45% of it is around analytics. Some 1% is around drones. Cyber security has been just 2% of it. Robotics has been some 7%, robots and cobots. IoT has been around 33% and automation has been around 12%. What does this signify? This signifies that analytics play a major role because we are still maturing this particular thing in our industry. And the second is we are in that phase when we are not realizing the importance of cyber security itself. Because moment we get into this, we also need to appreciate the threat which comes with this, which is cyber security, or rather the security aspects. So we need to address and appreciate that point as well. So this is how the industry typically looks like. As we are talking about use cases, we are talking about what has happened in the world. Let me give you a very classic example, something which is a role model, I would say, for the manufacturing unit, for the steel producers. So I'm talking about POSCO and how they have converted this entire story for them. I have a small video for all of you, and I'd like you to just go through this particular video.
POSCO ICT realizes a smarter manufacturing site by realizing the world's first smart factory on the continuous process, such as a steel mill. In Smart Factory, IoT technology is applied so facilities and machines exchange information themselves. All real-time data are collected from IoT sensors, and then every situation or problem can be monitored. After analyzing big data, the problem can be controlled and improved. Finally, Smart Factory will be realized with observability and controllability. Smart Factory realized by POSCO ICT diagnoses and predicts the state of facilities in real time by monitoring them with IoT. It inspects any facilities that can possibly cause a problem and deals with a possible cause of the problem in advance so as to maintain a stable work environment and extend facilities' life as well. The environment of Smart Factory collects and analyzes data of each work of the entire process in order to be aware of a cause of a quality problem in advance so as to minimize the rate of quality problems. Smart Factory, where workers overseas, provides a guidance for each situation for the optimized production performance by making experience of skilled workers into knowledge. Wearable devices help workers get support from an
This is
expert
Google Glass.
remotely in case of an unexpected situation in the field. Smart Factory monitors the field environment, such as vibration, noise, poisonous gas, and temperature of a workspace in real time, and notifies workers of, if any, risk elements in advance for providing a safe and pleasant work environment. POSCO ICT tries to resolve environmental problems caused by air pollution. It disposes of dust occurring in the industrial field using a high-voltage micropulse dust collector. And also supplies plasma facilities for desulfurization and denitrification. It will continue to aim for the coexistence of the environment and industry by supplying converged products that can deal with both dust and harmful substances henceforward.
Ladies and gentlemen, I was not showing you a high-tech movie, but this is something which was a use case. This was something which has been already implemented on ground somewhere. So you can imagine the kind of differences which we create versus the kind of differences which some of the global leaders are already doing. And there are so many things for us to learn from here. There are n number of use cases in this video itself, starting from Google Glass, where it was not something which was just a visual effect. They were actually connected from the shop floor to somebody through a Google Glass and were getting the direct guidelines and everything to rectify a particular machine. That's the kind of implications which has already gone into the, I would say, the digital aspects, the transformation, and that's what they call as smart factories. POSCO is smarting this entire steel production process through such initiative. And it's not only the initiatives to productivity, but also to address safety, also to address sustainability. You have seen in the last slide of the video that they were addressing how they reduce the air pollution which is created. So there are a lot of initiatives to get into the carbon neutrality through this kind of initiatives as well. So that's the beauty of AI, big data, IoT applications, which is happening and getting matured in some of these leading examples. If you get an opportunity, go and visit South Korea, this particular plant, and see that what kind of changes are there which is happening, and what are the things which you can take to your factory. Well, I'll not go deep into this particular point because I understand that that's the reason why we all are here, the benefit of AI, Gen AI in the steel industry. Because if I start talking about some of these initiatives, I'll be repeating some of the points which happened from the previous session. But just to quickly touch upon, we're talking about safe working conditions through AI. We're talking about process improvement, throughput improvement. We're talking about maintenance cost reduction. One gentleman from Tata Steel was mentioning about the cost aspects, reducing product defects, and improving customer engagement, rather customer satisfaction, customer delight factors. All those things are something which are the benefits of this implication of AI, Gen AI in the steel industry, and should be very closely looked at. But what is stopping us? If we understand the benefits, if we understand all those points, then what's stopping us? There are few and I'm giving you a macro picture, there are of course very case-specific examples. But when I look at the Indian steel players, in terms of adoption to new technologies, there are few challenges or there are few bottlenecks which have already been identified. The first is silo way of working, and I think I don't need to elaborate this much. You all understand that there are some departments taking up the role rather than collaborating with everybody, because one initiative somewhere definitely impact an initiative.
How many more slides you have?
I have just 3 slides.
3 slides.
Yeah. I'll be finishing in 3 minutes. I'll be finishing. So the point which I was trying to say is siloed way of working. That's one point. The second is resistance to change. We are very comfortable in what we are doing. That's second point. The third is high upfront investment. I think this is another area which gives a lot of pain that, okay, there are a lot of investment upfront, but people don't look at the bigger picture with the kind of returns which you're going to get out of it. The fourth is data management and integration issues. Different initiatives taken at different intervals and very difficult to integrate everything at one platform. That is a typical challenge of ERP nowadays. You have implemented one ERP, but all the initiatives cannot be taken to the same data lake or the same data layer, and that's the reason that you are paying a lot of cost. So that's another thing. Poor data quality and consistency. And the last is right talent unavailability. I think this is another point which is to be addressed carefully. I'll not go deep into this. There are n number of use cases. I've already shown you a video, and I'm not going to talk about all these initiatives now, looking at the paucity of time. But starting from mining to beneficiation to iron making, steel making, up to sales and marketing, all those, every node has one or the other use cases through AI applications, through GenAI applications, digital applications, which can be looked at. Many of them fall in the analytics. Many of them fall in the EBITDA improvement and such kind of aspects. But the core is digital network, IT/OT integration, cybersecurity, and cloud-based data platform. Some of the initiatives which is required. I think some of these initiatives are again use cases. I'm not going to get into this. Let me come to my last slide, and I'd like to stop here on this particular slide that the investment or the digital adoption in the steel industry is going to be almost 2.5 times by 2030, next 5 years. So what does that mean? That means that there are certain way forward, there are certain points to ponder upon. The first is such initiatives should be taken up by C-suite. From the CXO level, leadership and organization alignment is required. It cannot be taken at one part of the department, driving one initiative, and ultimately, doing some flashy thing and not making it sustainable. Very important that sponsors should be leadership. The second is readiness for adoption of technology, which requires a lot of aspects focusing on the cybersecurity and such elements. The third is innovation and collaboration. I think there are a lot of people from academia who are here. There are a lot of people who are the R&D who are here. They play a very important role in bringing the outline of what is happening globally, what are the technology changes which are happening, what can be done beyond what we are doing. All those points typically come from R&D. So there has to be some funding, some important funding in the R&D side as well. Fourth important aspect is upskilling ourselves. And when I say ourselves, means all of us, considering we are the workforce. It's very important for us to upskill ourselves. Regulatory support is also something which is required. There has to be some elements from the policymakers saying that digital is important in our day-to-day life. And the last is adoption of future digital technologies. One example I just showed you. Similar examples are there. Multiple similar examples are there. We need to go through them. We need to see that what are those use cases which we want to adopt. Well, adoption is for us to look at. The change is on us, how we are going to adopt it. So with that, I'll close my presentation. And if you have any points, maybe you can catch up with me during the lunch. And my coordinates are here, always available to support, help, and discuss. Thank you. Thanks for hearing me patiently. Thank you.
Thank you, Tushar. You had thrown some glimpses about industrial symbiosis, actually, and integration. But I thought you could cover more there, and also something on smart factory. These were the two interesting points. With this, I would now request Mr. Nicolas VIENS. How do you pronounce it? VIENS or VIENS? VIENS. Okay. And from France, who is a PhD scholar in engineering sciences, and he has a large professional experience in industries. I mean, it's difficult to find out which industry he has not been associated with. Aeronautical, automotive, nuclear, and level 2 systems of steel industry. Now, without wasting more of time, request Mr. VIENS to proceed with his presentation. And please, we'll adhere to the time limit set so that others can.
Thank you, and I'm glad to meet everyone, and thank you for the invitation. So at first I will present fifth group. We have 4 main activities with multi-sector of expertise. We have process technology, high precision machining, smart automation, and some transversal activities that are maintenance, piping, and also AI and data processing that we will ask today. We will discuss today. Okay. And we provide also some global solution as reheating furnace or steel processing for coil processing, and also some services like process expertise, spare parts, and also digital solution. So I am a member of a team that called Steel Digital Factory, sorry. And the aim of this Steel Digital Factory, what we composite, it is to make the union between many skills and many know-how, many knowledge, as all actors from steel process, as metallurgists and process experts. The equipment, as we are equipment providers, we could also imply all designers and also imply some IT developers to give a reliable solution. And so we are able to provide some technical supports for market analysis and investment strategy, but also for process audits, support for product development, and also for ramp-up and industrialization operation. At first, I want to share with you a global view of our digital solutions. We have one layer for control solutions that are virtual solution, level 2 solutions, and smart line solutions, and also a global solution for quality management and what it is the difference between those two solutions. It is the level 2 solution has to take some decision in 1 second. It is live decisions, and so to implement some AI, it is more risky because we are managing the equipment. And for quality management, we have to take some decision only after one or 2 minutes to adjust the process. So it is also enough risky, less because it is not in the second, but it remains a short time. I will introduce the global solution for heating furnace. So the aim it is to have a modelization of the product. And since we have modelized the product, we could have a dynamic control of each zone inside the furnace. And what does it imply? It implies that we could optimize all the heating process with an optimized heating curve, that it is computed based on the enthalpy and some strategy of control. But we could also have live correction with AI model with the mill feedback to adjust the discharge temperature to reduce the standard deviation at the mill process and center the target of temperature at the mill process to the measurement. So it is the first example of AI that we could deploy on our solution. We deployed it on a case study in North America, and the whole solution was able to save about 4% of gas consumption, and it was fully automated during almost 3 years since we have implemented. The second solution, it is a smart line solution. So I will introduce a smart line because it is a more complex control system, because we have a master model that it is capitalization of all knowledge for process and quality, know-how and knowledge, and also for metallurgical knowledge. This master model will feed all other systems that are furnace model, level 2, but also we will have the sink bath model that will control the level of the bath, and air knife model that will control the thickness of the layer of zinc, and also skin pass mill. So it will feed all level 2 system, and after level 2 system will control the heating, cooling, and the coating. So during the process, we could optimize all transition between all products variation. We could also optimize the heating and the cooling of the coil during the process. And we could for cooling system, we have developed some AI model that will control directly the cooling system to take into account all the link between sometimes slow cooling and fast cooling, and because often they are controlled together, and dispatch the best set point to the level 1 system. We deployed it in Marcegaglia in Italy, and we have really good results of the smart line. In the global smart line, we have increased about 6% of productivity. It was used for almost 100% of the production, so almost always, and it was more than 5% of energy savings. So it is the second case of AI application. And the last one, it is the iron solution. So the iron solution could be deployed on a whole plant. If you have more than, you can deploy it on many lines, on many furnaces, everywhere, from the upstream to the downstream. And this solution will take all the data from all systems on the whole plant, or we could deploy it also on many plants. Even some laboratory results and steelmaking, casting, or trolling everywhere. One kind of application that we could make by AI, it is to work with metallurgists to define to define each defects, to work on the detection of each defects and analyze it. And what it is interesting after, it is when you can classify automatically your production and your defects, you could also start to make a root cause analysis identification, because you have all information in the same system, and you could make some discrepancy on you could make the link between the parameter of production and the defect, and you could advise the process engineer to how to modify the process to optimize the quality and so increase the yield. So this kind of use of AI, it is really important to, at first, identify the defect, have a well classification of it, and after to improve quality with process engineers. We have deployed it in RVD steel coil, steel plant, where the difficulty it is that they have 11 different quality levels. They have almost 100 final users, so many difference on the process for each users, and each knowledge for each user has to be always updated, and it is complicated to update it for each final user. And we deployed it since 3 years, if I remember well, and we have seen some improvement on each part of the whole process. It was really interesting. So there was many savings. We reduce scraps at continuous casting. We reduce the cold shake also during the production, and we reduce also scrap at Z mills and CAPL. We have already deployed the last 10 years our solution over more than 40 sites, and we continue to deploy it also in India with our partners. It's okay. Thank you very much.
Thank you for finishing well in time, and particularly what was very interesting is you tried to bring out through certain case studies the application of modeling and AI in defect analysis, and the coil intelligent analysis also, the iron process, which also involved intelligent processing. Those were two very interesting aspects. So thank you, Nicolas. And now I would request my old friend Praveen. He needs no introduction because he has been with Tinova now for a very, very long time. Except that we'll now look to hear from him what additional he has done. Looks like he has done some work in some niche area of electric arc furnace. So we'd love to hear that.
Thank you, Professor Sen, for, for your kind words. And good afternoon to all of you. I know time is quite short. And I will show my presentation at a bullet train speed. Rather, Vande Bharat I can say right now. Later on, once it will be commissioned, then I will say bullet train. So here we are talking about application of the AI tools for cost cutting, cost effective and sustainable steel making. Means we can say that yes, we have to maximize our process efficiency. And this is nothing new subject for this forum. This we have discussed last decade. You can see the presentation here. Mr. Pritish Sen is appearing, Mr. BP Sarkar is there, and it is 2012, the same forum, same location, and optimization of iron and steel. In that, it was already discussed that how we can reduce the dependency on the human being. So this was the concept which we discussed, and in continuation to that, AI has now come into the picture. So AI isn't replacing human, it is only improving the human capability. This was the discussion what we held in 2012, that something should come. We have to reduce the manual intervention from the safety point of view, from the operational efficiency point of view, and now this is come into the reality. Yeah, of course, I'll going to skip it. This is just our company profile. We are 36 billion company, and we ourselves, we make the steel under the name of Tenaris and Ternium. We are part of the Tech group, and more important that we are also making the steel in a sustainable way. We have been awarded a sustainability champion by World Steel Association, our sister company Tenaris and Ternium, you can see in the bottom. And this is what about our profile is. We are basically the technology supplier for metal and mining industry. We have our TechRAF, our TechRAF and Delcor people are also present here. And we have our global footprint. And that is why sustainability has been the new mantra which has been given to us. Of course, we are into electric arc furnace and submerged arc furnace, reheating furnace. We are into that one. But coming to the topic, the challenges what we are facing, we have discussed in the previous session. Yes, sustainability, starting from the safety, efficiency, carbon footprint, and of course the flexibility, we have to be market ready. So these things already we have been discussed in the previous sessions. Yes, we have the solution as a part of Tenova. We have the answers. I'll very quickly touch upon about the technologies what we have, and then we'll come to the AI. One technology what we have is the cone steel, in which a scrap gets preheated, and this is, we call it cone steel. And any type of a scrap, we don't need any processing of this scrap. We have more than 200 such installation. But how the AI is coming into the picture here is, we did a project in Ori Martin in Italy. Here you can see that since we are dealing with the scrap-based electric arc furnaces, so we have to do the classification of the scrap, because we don't know, the scrap is the such thing that that is not in our control, and what scrap having all the tramp element. So first of the things that we first of all identify those scrap from the beginning. You can see the picture which has been taken from the truck, which is coming, truck or even the wagon. It is coming from there itself. We start our activity, and we identify which type of scrap is coming, and then we classify all the scrap. You can see whether it is rod or metal or sheet, and then we do the analysis, and then we do the tracking. This is the live tracking. Okay. You can see here that, yes, we do the live tracking of the same. Of course, I'm just skipping it. The main thing is that we also identify the type of scrap, the slab, the supplier from the tramp element, whether it copper is present or other items are present. And then we classify, and then we do the analysis prediction. Another important aspect is about the DRI. Yes, we are the DRI maker. In our DRI plant, you might be aware, energy RN HOL technology, in which natural gas, reformed gas, syngas, coke oven, or even hydrogen, if it is ready, which can be pumped without change of the process scheme. More importantly, we have the CO2 removal system inherently in our system, and we produce high carbon DRI. That is, it goes up to 5% carbon. More important, the carbon capture. Yes, already it has been in practice. We used to capture the CO2 and use it for various purposes. You can see there are various off-taker companies. They use it for food and beverage industries, dry ice, and oil recovery, or nowadays people are talking about ethanol and methanol. Usage of the hydrogen is nothing new. We have been using the hydrogen since many years. 1957 onwards, because you can see the plant what we are having. Already we are having more than 70% of the hydrogen we are using, but these are not green hydrogen. These are basically the hydrogen which are coming from the natural gas or the coke oven gas. And yes, downstream we have the electric arc furnaces, which can be fed, either DRI can be fed into the electric arc furnace, or it can be converted into, melted into pig iron, and then it can be used. Flexible modular furnace, which in the previous session Mr. Nandi was mentioning that in GSPL they have implemented. We call it flexible modular furnace. This is a picture of the same GSPL Raigad, in which the furnace can operate in both the ways, either with the electrical 100% electrical mode, or it can go up to the without electrical power, and that is the flexibility it has. It works only on the chemical energy, just like in a BOF process. So these systems also we control by AI. How much will be the feed rate of the hot metal clubbed with the chemical system. So we basically regulate this thing with the help of the AI. And then come to the continuous feeding of whatever charge mix has to be fed into the furnace. It should be controlled in a continuous fashion, whether it is the scrap or hot metal or the DRA. This is the flexibility what we have in our flexible model furnace. Coming to the topic, what we are discussing is Industry 4.0. You know, the Industry 1.0 used to be steam, and then it came energy, then it came automation, and then now we are talking about the internet now today, that is 4.0. More importantly, how this AI works. It doesn't work just what Dr. Debashish was mentioning in earlier. It starts with the logic. It doesn't. It's not some magic. It's a logic basically. See, the challenges what we have to address is ore. Of course, it is not in our control. Whatever is there, good quality ore is not available. Then availability of the reductants, and then power cost, it's going up, and then our environmental aspects. So logic point of view, say how furnace is designed and how AI comes into the picture, they do by the mass and energy balance. For example, how much energy is going, what is the raw material it is going, and then what are the losses, then what are the outputs, and considering the fumes which are coming out. So basically, it starts with the first principle. So there should be a logic, and based on that, rather than noting on pen or paper, all those things are recorded automatically, and in a closed loop fashion, it also guides us, just like GPS in a car. How it takes the figure there is some logic in which it is letting us know that at what point we will reach the destination, how much time it will take. So in the background, what it helps us to optimize it. This is the topic what Mr. B.P. Sarkar has mentioned in 2012, that we should make the steel, not for making the steel, but in an optimized way. The one important thing is the continuous measurement of the process parameter. There should be a proper sensors, probes, which should measure it accurately, and then we can do the analysis, model analysis. It is a dynamic model, not the static model, not the statistical model. It's a dynamic model. Second by second, it changes as per the real-time scenario in the steelmaking process, and then finally it controls. So this is how the philosophy works. In Tenova, basically we work in both the ways: machine, software, and experience and know-how people. This is what Dr. Debashish has mentioned in the beginning, that there should be core. It is not that AI people should run the steel plant. The steel plant should use the AI to run the steel plant. So this is the difference. And this is how we do. This is the digital product what we have in our Tenova portfolio. And yes, earlier we used to call shift foreman. Now it has been replaced by digital foreman. We call it digital foreman. Basically to AI, we used to call it digital shift foreman rather. And we have the system called iMelt Shop. And as I mentioned, your real time, it measures it. We do the mass and energy balance, and then it predicts the endpoint, what should be the carbon, what should be the temperature of the bath. So if Neil Armstrong can go to the moon, what Dr. Debashish has mentioned, yes, why can't we predict the endpoint temperature and carbon? So these are all based on the automation, having the proper sensors, real-time model, and a proper algorithm. And this is how those furnaces, electric arc furnaces works. I'm just skipping it out because these are the various models. It has been explained here. There are various tools which measures the whatever parameters are going into the furnace. Of course, it is from the level 1, or it can be from the level 2. Because more importantly, that if we are able to measure it, then only we will be able to control it. The simple logic is that whether it is for our medical science, we go to the doctor, first of all, they do all the diagnostic testing. The more accurate it will be, then it will give a remedial cure. Then it will prescribe some medicine. So that is why we should think that steel making is just like, there is no difference between medical science and the steel making. So we should think that steel, what we are making, it is just like our human body. And then only we will be able to correlate. So this doesn't happen with artificial intelligence, but it is from the human intelligence. So, yeah, these are the sensor and tools which measures in electric arc furnaces. I'm just skipping it out, how this model works, because this can be discussed. Yeah, in real time, what is happening in the furnace, we are measuring all the gases, we are measuring the bath temperature, bath chemistry, and there are various models, of course, that can be applicable, whether it's for the scrap-based furnaces, hot metal-based furnaces, DRI-based furnaces, and henceforth. And the same thing, this is what we have mentioned here. Yes, I'll take a very small example here. You can see the flute. When we play the flute, there are various holes. When we close the hole, then the sound changes. But this we can hear and we can analyze, because we are not like bat, that we can hear some ultrasonic waves, or we are not just like ant. So, just like flute, we also design the system. There are various systems which are integrated in our furnaces. Those are water-cooled system, in which if there is any leakage, we'll be able to, with the same philosophy, we are able to hear the vibrations. If there is any particular leakage with our sensor, it records, it identifies the spot where is the leakage. that is of course the acoustic type, and then it gives us the real alarm that yes, from where the arc instability and considering the those harmonic trends, it predicts us. Likewise, likewise in the lateral tracking system also, that we have to define these are all done online through these AI models, and these are some of the historical trends which we measure, and then we predict that what should be the live doing the thermal mapping. And more importantly, I know Dr. Professor Sen always says that whatever you do, it should be quantified. It should give some benefit. It should give some results, savings. And what all the things which I am showing, it definitely helps us to give us quantify the efficiency of the lateral, efficiency to reduce the accident, enhances the refractory consumption. So those are the things which has to be taken into account. Other way is this, tapping. So there are various models in which we do the slag-free tapping, in the sense we can see, because you know whether it is slag or metal, they have their different wavelength, emissivity is different. So this Planck's law we apply here, and then we say that how much slag has really gone, which is how much is permissible. So we call it slag-free tapping. There are some videos which really help us to measure that how much scrap has gone. It reads how much liquid metal has gone, how much scrap droplet has gone, and when to stop and do the tilt back. So you can see here, this is the picture which our naked eyes cannot see. Our digital method reads, and it records also if something has happened, and then later on we can do the postmortem. Rather than doing any postmortem, it real time improves automatically that in next heat there should not be any problem, or it stops then and there. So these are the savings is there. It reduces the power on time, also helps in secondary metallurgy addition of any aluminum or any stuff to eliminate the slag. The basic thing is that it is not by experience, not by statistical model, but since, as you know, that if there is no particular information, it is very difficult to predict that where exactly we have to go. So basically, as I told you, that we do the mass and energy balance. If we have the measurement, we have the knowledge, then in a precise way we are able to control it. And if we are having the missing data, then there will be a lot of assumptions. We have to depend on the human skill, and then there will be a chances of error. So these are some of the things which are applied, because the furnace, electric arc furnace or any furnace doesn't know what are whether it is light scrap or denser scrap. So if we are going by the same kilowatt hour per ton basis, then light scrap will melt, but heavy scrap will not melt. So that is why here more important that every heat, just like one body, human body and another body, they are not identical. Likewise, one heat to another heat, they are not identical. Everything, many things, all the things almost it changes, whether it is raw material or its efficiency. So that is why we cannot keep on working on the traditional model. So we have to consider all the losses, and it should be designed such. And yes, this is more important that we have to also recover the energy, whatever is there. And here you can see we are recovering the steam for generation of various internal purposes. And basically, we are looking through the sensors and probe inside the furnace, what is happening inside the furnace, to have a precise knowledge. Just like, you know, doctor, they does with various probes and all, they measure our body, what is the temperature, what is the blood pressure and all. So this is real time, we are getting the information, and automatically it controls our the furnace operation through the various models, mass and energy balance. And this is how we ensure that, yes, our whether it is light or heavy scrap, we are able to process the heat. So these are some of the sensors. I'm skipping it out. It can be applicable whether it is shaft furnace or whether it is traditional top charge furnaces or electric arc furnaces. It makes no difference. We are able to do it. More importantly, again, I'm emphasizing what Dr. Professor Sen says, that everything should have give some benefit. You can see the benefits what we have given here in terms of electrical energy. This is the guarantee we take it, because whatever automation or whatever AI we has to do, at least it should have economic value. Return of investment should be there. So you can see in the terms of yield, not only in US or Europe, you can see in North America, even in Europe and Japan we did it, Mexico, Southeast, Japan. So you can see there are n number of references which we did it. And also it helps us to reduce the carbon footprint, which Professor Sen was mentioning, that yes, there are a system in which we can control how much hydrogen should go, and then how much CO2 footprints are getting reduced. You can see these are the things which we have already implemented it, and it helps us to reduce the carbon footprint as well. So here I would like to just add that by using all those models, thanks to this 4.0 solution that are based on AI models, and with our own patented software and hardwares, we ensure that KPI are here to stay. You can see in the last line, they are here to stay. It is not that we have put it and then we go out. They are going to last long. So of course, these are and the same system can be also implemented in BOFs. Whether it is slope control or endpoint control or auto tapping. So all those things system are also applicable to the secondary metallurgy, whether it is VOD or AOD. Yes, this is the one of my last slide, in which nowadays the same type of AI we are using for the Indian rare earth, not Indian rare earth, this is rare earth extraction. Of course, Indian rare earth provides the material, but since we are talking about the critical material, magnet, permanent magnet, yes, we have the full supply chain. We provide the solvent extraction. Our team from Delcor and Techcraft, they are present here if you want to have a discussion on this. So we have developed our own electrolyzer, which makes the NdPr oxide to NdPr magnet, which are used for making the magnet. Yes, which nowadays we are in discussion, and we have done in MP material in Texas, US, which has been successfully implemented. More importantly, this is for the new generation, which Dr. Professor Sen should also agree, that I'm not worried about the rise in AI. Yes, we all do. But we are a little bit worried about the decrease in the real intelligence, mainly for the young people. So I think we should take into the consideration. And sustainability, this sustainability should come from the heart, not by the brain. So this type of things also we should develop in the AI, because it thinks from the brain, but it should come from the heart. Thanks. Thank you.
Thank you, Praveen, for the type of presentation which I'm accustomed to hearing, and a wonderful one too. Comprehensive, which has covered several niche areas. But what was surprising for me is that you are getting into neodymium recovery as well. But you will have competitors in Gujarat. You know that. They are already producing that by electrolysis. The route is the same. So although it doesn't fall strictly within what we are discussing, I thought I'll share this information with you. Thank you once again. Thank you.
Thank you, sir.
We have the last speaker. He is the Assistant Vice President, Primetals, and basically a computer man, master of computer application, and we look forward to hearing from him.
Good afternoon, delegates. Good afternoon to Chairman, sir. The basic idea of this presentation is that there is a huge hype that AI can solve all our problems. Of course, AI can support in many areas, but in production system like steel industry, we have to take care of the mistakes which AI is doing. I will start my presentation with some of the quotes It is all about data, but it is not only about the data. Now there is new verse is that data is the new oil. Of course, data is important, and the importance of the data is long known to us, but we have to take care of how we use the data. The world's most valuable resource is no longer oil but data. Yes, that is true. And the goal is to turn data into information and information into insight. Like we have the raw oil and we have to distill it and then we get the gasoline. So we have to refine the data to get the informations, then we are really benefited. Data, as Professor Banerjee also said in that data is very important. The quality of data is very important. If we put the garbage, we will get the garbage. So data is like garbage if you do not know how to use it. This is a sidekick for many of the thinkers that first we collect the data and then we think about how to use it. But this is not the correct way. We need to first think what to do with the data and then collect the data. The data and information without action is useless. We know that what are the data available, how to use it, but we do not take any action, then there is no meaning of that. There is no growth without this. So now what to do? How the data become effective? There are three aspects: the quality of data multiplied by quality of knowledge, and then degree of actions we are taking on the data. As far as quality of data and quality of knowledge is concerned, support of AI methods can be utilized in these ways to get the quality of data and quality of knowledge. So what do you have to consider when using AI in industrial environment? The quality of data, first aspect. You know, in normal scenarios or normal applications, for example, we have many examples like shopping portals like Amazon, like other big baskets, all these things. They have the data points, very less data points. And you have the credit card number, you have your postal address, you have this article number, and you know all the data points are correct. And they are independent of each other. But in our steel industry, we know that the data comes with an error. We get the measurements from the field, and there can be some errors. We have to deal with this error. And in normal applications, the number of transactions, as I giving example of portals like Amazon or any other things, the number of transactions are too much, and they are independent of each other. But in our steel industry, the number of records, number of transactions may be small, but they are not independent. They are dependent on each other. They are dependent on various aspects. And the number of data points are too much. For example, for a quality aspect, if you start from the beginning to the finished product, we have 8,000 to 10,000 data points which we need to consider before getting to some conclusions. And other way also is that the complexity of the data. In our industry, the complexity of the data is very complex. For example, in a single unit, we have an optimization system. The database for a single unit itself is complex. And we are dealing with so many of aggregates in a steel plant, and we have to deal all of with them. Now we have to consider other dimensions of the data. More than 80% of the effort in data-driven methods is accounted for data preparation, like completeness. When we are using AI, when we are using train our models, then the data, we should have the complete data. Complete data means what? We are training the models with the data, and we should have both the good and bad one. Then it understands which data is good, which data is bad. So we should have both types of data, then the data is complete. Timeliness. For example, sometimes we need the laboratories data, and it is not coming in the perfect time. So there is no meaning of this analysis if we are not getting in the timely manner. So timely manner is also important in case of data. Relevance, we should have the relevant data at the relevant time. Otherwise, it is useless. Accuracy, the data should be accurate, but we know that it cannot be completely accurate. But we have to deal with this, we have to take care of this, and the data should be consistent. The data should come in a proper time, proper consistency, in regular ways. Then all this aspect we have to consider before accumulating the data. Now the second aspect is the quality of knowledge. As we know, in the steel plants, we are running any aggregates or any plants. The operator have the experience, have the knowledge, and depending on their experience, they are running the plant. Some are very good operators, some are not running that efficiently. But if we digitize those ideas, those things into the knowledge, into the digitized form, then we have the solid platform to use the AI, to go ahead with the standard manner, and we can improve continuously. Otherwise, and we can have a platform of 20/7, the same thing we have, we can improve continuously, and we do not dependent too much on the good operators to run the plant. Third thing is the transparency and traceability. For example, if we have certain assumptions or certain conditions and certain predictions is giving, the system is giving certain predictions, and it is not let us know how it comes to that conclusion, then there is a lack of trust. The responsible person cannot trust the system, why it comes to such a decision. In that case, our system should say that why it has come, which rules it has applied to the system to come to this conclusion. This is very important. Now the third aspect is degree of actions. As you know, in our conventional way, the process engineer give the knowledge to the operators, and the operators has the information, have the data from the fields, and it get informations from those data collected with some optimization systems. Here, if we digitize our system, our knowledge, and we continuously improve our knowledge base, then we can, always improve by this knowledge base, by digitized base, as I told before also, that we do not need to depend on the good operators. We can run the system in a better way. And also, the collected data we can use for data analytics, for business intelligence we can use, and by these data, by this intelligence, the process engineers' insight is more increased, and they can train the operators in a better way, and after the training, the operators can operate in a better way. So, what are the solutions we are providing with AI? I am giving you some examples how we are improving. Like artificial ear, the ability of baghouse in filter systems. The problem is that the condition and operation of the filter cleaning have a major impact on the overall performance of a bag filter system. Error identification is time consuming. How we are giving solution for this? We are using acoustic sensors act as an artificial ear. Noise is analyzed in real time and derivations from the norm are identified. Automatic detection of pressure leaks and the condition of all cleaning valves. So another example I will give you, artificial eye. That increases the production reliability. What is the problem issue? The problem is that the belt shear trim the steel strips. If cut-off residues remain in the belt shears, damage to the belt and plant equipment can occur. You see here how we give the solution with AI, with the help of AI. Camera-based AI detects cutting errors and stuck strip sections. Automatic notification to the process control system. And when we have all these measurements, all these technologies in the system, then we have the cockpit, operation cockpit, centralized operation cockpit, where we show only the relevant data. If in a plant, if you give the operator all the access and he has to take care of all the cameras, all the sections, then he's puzzled. He cannot take access. But in our system, we have developed the system where the relevant data or relevant picture is shown to the operator, and with the analysis with what is going on, what has happened, and what action has to be taken. And this technology we have used remotely also. So now basically in future the operators will become basically more of not the operator but a supervisor. I give you an example. Mr. Chaturvedi has already given the example of the EF. So the most two valuable thing in the electric arc furnace is the scrap, and another is how the operator runs the furnace differently. So with the help of AI, what we are doing is that we are gathering the best heats which has been produced. We are gathering the data, best heats used, and take the data from these heats and put it into the process optimization system, and where we can use this data to generate the best hits, and we do not dependent on the operators. Another example is that the prediction of temperature in the blast furnace. We can take only actions when we know the measurement when we are tapping. But with the solution of AI, we can predict the temperature 2 hours before with a correction of 10 degree plus minus. So it is a huge relief to the operators, and we can predict these temperatures and silicon contents. I am giving you an example of a plant in China where we have used our through process quality control system with the 2 production sites, 6 ton production units, 6 surface inspection system, more than 8,000 process parameters, more than 100 KPIs, more than 400 rules, and we were collecting more than 50 GB of data storage per day. And the main functions we have provided with this technology or this process is that automatic grading, root cause analysis. We can have with this data the entire genealogy of the product. In future, if some complaints is coming, then with the available data, we can find out, we can dig back where is the problem occurred and how it occurred and what can be the solution for this. So there are some other examples, but the lack of time, I can skip for these examples. Now we have the other systems like LX systems. It is the asset life expert. In a normal conventional CMS, we are depending on the vibration monitoring. We give certain, we have the sensors, vibration sensors, where we give alarm if the values goes to a certain value. And the operator has to decide what to do. He has to think about how to act. But in our system, we have much more sensors. We are utilizing the automation systems which are available. We are using those parameters, and we have the complex monitoring and inspection prediction system. And we are giving the root cause where the problem is occurred and what action is to be taken on those areas or in those problems. And with the HMI, we can show what actions to be taken. So the operator life is much more easy, and it cost the preventing maintenance is better way we can use it. So in summary, there are 4 aspects of the data. The data quality must be good and meaningful. We have to use the AI methods. There are different AI methods. We have to case basis, we have to utilize the AI methods. We cannot fit all the AI methods in all the areas. Effectiveness, as I told, if you do not take actions on the data, you know what to do, but you do not act, there is no meaning. And 4th is the transparency. The system should tell us how transparent, how it comes to such a conclusion. This is very much important. Now, in our parameters technology, we have a dedicated analyst which are analyzing with the data. We have the domain know-how. We can say we are long time in this field, so we know the equipments, we know the things much better way, And we have the team of statistics which are playing with these data, developing the models, and with the help of machine learning and programming ITs, we are developing the successful AI in metals. And we have collaboration with more than 8 universities and external research partners. So thank you very much. This is.
Thank you for your comprehensive presentation. I have just one curiosity question. With the success of your I4 technology, number one, are you trying to bring that in India?
Yes, yes, we have.
You have brought it. And the second question is, can AI be used to forecast renewable output and align electrolyzer operation with the steel plant needs? Because you know our system, you have a complex system. There is a conventional behavior followed by this. So can you do that through AI?
AI we can use, we have the data, we have the things, we are developing the models, but with a certain range, we can say that within this range we can have. You cannot predict, as the data, the rich data you have the rich predictions. So it all depends on the data. So as I
The
told
type
that
of
within
data,
the-
basically.
Yes.
Yeah, thank you. Thank you.
Thank you.
So this brings us to the end of the session. I think you all must be awaiting your lunch. I have no further questions. And perhaps we can declare the session as closed. Thank you.
Thank you very much, Professor Sen, and for the presenters. May I now request Dr. Roy to do the honor of giving a small gift to all of you. To Nicolas, I think. Yeah. Thank you, sir. Tushar. Thank you very much, Professor Sen and all the presenters. Given an excellent presentation and big round of approach.